Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to the International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2023. It is a great honor for me, Zafran, and my partner, Dara, to be standing here and welcome each and every one of you in this wonderful event. Before we begin our wonderful event, we would like to thank our sponsors for making this event possible. They are PT Indonesia 17 and PT BNI Tbk.
And before we begin our spectacular event for today, let us thank Allah Subhanahu wa Ta'ala who has given us guidance, happiness, health, and mercy so we can attend and participate in this special event without any obstacles. Praise and salutation upon our Prophet Muhammad Sallallahu Alaihi Wasallam who had brought us to the path of light from the darkness in this life.
The Honorable Rector of University of Mataram, Professor Insinyur Bambang Harikusumo MAgr ST PhD, which would be represented by Vice Rector for Planning, Cooperation and Information Systems, Professor Akmaluddin ST MSc Engineering PhD.
The Honorable Governor of West Nusa Tenggara, Dr. Andes Haji Lalu Gita Aryadi MSI, which will be represented by Haji Wirawan Ahmad SSI MT.
The Honorable Dean of Faculty of Engineering of University of Mataram, Muhammad Syamsu Iqbal STMT PhD.
The Honorable Dean of Faculty of Engineering of 11 Maret University, Dr. Tech Insinyur Solihin As'ad MT, which will be represented by Professor Dodi Aryawan STMT PhD. And to all the participants who have joined us today.
Before we start our wonderful conference, let us elaborate the agendas for today. The first, we'll be having an opening ceremony which includes singing the national anthem, speech by the chairman of Icimece, and speech by the Dean of the Engineering Faculty of University of Mataram. And then we'll be having a performance by the Warung Seni, and we'll have speech by the Governor of West Nusa Tenggara. And then we'll be having a photo session, coffee break, and then we'll be entering the panel session, which will be divided by 3 sessions and will be brought by 6 keynote speakers.
And for our first panel session will be brought by Professor Josaphat Tetuko and Professor Nafarizal bin Nayan.
And for our second panel session will be brought by Professor Kang Hyunjo and Professor Igede Pasak Sutawijaya.
And for our final session will be brought by Professor Takahito Miyazaki and Professor Hasnan Abimanyu, and will be followed by lunch break and parallel session. Before we start our event for today, let's recite Basmalah.
Bismillahirrahmanirrahim. Ladies and gentlemen, for our next agenda, for today we will be singing the national anthem. To all the participants, please stand up. Ladies and gentlemen, you may be seated.
Ladies and gentlemen, before we go much further, let us welcome the chairman of Icimece 2023, Joko Haryono STM Engineering PhD, who will give an opening speech for this wonderful event. To Joko Haryono, the stage is yours.
Thank you very much for Master of Ceremony. Good morning, everybody. Assalamualaikum warahmatullahi wabarakatuh. It's my pleasure to welcome all of you to International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2023. I would like to extend special thanks to Mr. Governor, who has represented Rector of Universitas Mataram, Dean of Engineering Faculty, Universitas 11 Maret, all the distinguished guests and participants, also the committee of the conference. This year will be its conference, so 9 years before we has passed in the same conference. The theme of this year is empowering innovation to green technologies for better sustainable future. From this, we also want to extend special thanks to the speakers who have come from abroad. First is Professor Josapat Tuko Sri Sumantyo from Siba University, Professor Nafarizal Binayan from University of Hussein On, Malaysia, Professor Kang Hyunjo from University of Ulsan, Republic of Korea, Professor Igedip Paseksuta Wijaya from Universitas Mataram, Professor Takahiko Miyazaki from Kyushu University, and also Professor Hasnan Abimanyu from National Research and Innovation Agency. We also appreciate for all the authors from the 7 countries. We have 187 submitted from this conference. Among them, 141 will be presented in this conference. The affiliation from 7 countries. First is from Peru, Japan, Republic of Korea, Malaysia, Sri Lanka, India, and also Indonesia. We perform hybrids, which 42 center will be present on in-person mode, and 99 paper will be presented in virtual mode. Thank you also for our sponsor, and they are here. My respect to Mr. Andi Sugiono Nugroho, Chief Technical Officer from Indonesia 17, and also officer from BNI BK. We hope everyone have a great time to share their expertise with us in Icimece 2023. Welcome to Lombok, welcome to Indonesia, and welcome to Icimece 2023. you.
Thank you, Joko Haryano, STM Engineering PhD, for the amazing speech.
And now for our next agenda is an opening speech by the Rector of University of Mataram, Professor Insinyur Bambang Harikusumo, M.Ager, ST PhD, which would be represented by Vice Rector for Planning, Cooperation and Information System, Professor Akmaluddin, ST MSc Engineering PhD. The stage is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera buat kita sekalian. Good morning everyone. Alhamdulillah wassalatu wassalamu ala rasulillah wa ala alihi wa sahbihi wa man walah, la hawla wa la quwwata illa billah. The Honorable Official Representative of Governor of West Nusa Tenggara Province, the Honorable Dean of Engineering Faculty Universitas 11 Maret Surakarta, which is presented by Vice Dean of for Academic Affairs, and the Honorable Dean of Engineering Faculty Universitas Mataram, Head of Vice Dean, Head of Study Program of both maybe attendees here from UNS and UNRAM. Our distinguished guests, participants, ladies and gentlemen. First of all, let's thank Allah Almighty God who has given His blessing and mercy so we can gather here in good health and good condition without any obstacle. Praises and mercies to the Prophet Muhammad, peace be upon him, who has passed down the Quran as guidance for human being living in this earth. May Allah guide us the right path to follow His messenger's guidance. Amin. Ladies and gentlemen, it is a great pleasure to welcome you all to this place Lombok Raya Hotel, located at the city of Mataram, which is the heart of the capital of West Nusa Tenggara Province, where also the University of Mataram is located. Being the Vice Rector for Planning, Collaboration and Information System of Universitas Mataram, I am honored to address this 8th International Conference on Industrial, Mechanical, Electrical and Chemical Engineering 2023, Icimece 2023, which is being held jointly between Universitas 11 Maret UNS and Universitas Mataram in the form of hybrid conference, attended in person and virtual. This is a truly unique platform for us to come together and shape the future of sustainable development, and I'm really grateful. Our distinguished guests, ladies and gentlemen, I'd like to take this opportunity to give you all a brief introduction about Universitas Mataram. Our university was established on 1st October 1962, and now at the age of 61 years, we offer many courses and programs ranging from diploma, undergraduate, to postgraduate, including master's and doctoral degrees in the field of agriculture and animal science, law and social sciences, tourism, management, business and economics, education, engineering and technology, environment and natural sciences, and medical health. Universitas Mataram boasts of being one of the largest universities among the some universities in the eastern part of Indonesia. We manage 34,000 student bodies spread across the 70 study program under 9 faculties. Mostly study programs are accredited very good by Indonesia Official Accreditation Board. Universitas Mataram, with its status as a public service institution, now has 1,342 lecturers and administrative staff of 1,583. Meanwhile, the number of professors is 96, a significant increase compared to last year, which was only 54. And now the number of professors who are in the process of being nominated is 35. So the target in the early 2025 can be achieved at least 125 professors. Esteemed participants, ladies and gentlemen, I am delighted to stand before you to inaugurate this conference. With the theme of this year's conference is Empowering Innovation Through Green Technologies for a Sustainable Future. This theme could not be more relevant to the time we live in an age of the technological advancement and globalization. The field of engineering, science, and technology plays a pivotal role in shaping our understanding of the world and the way we interact with it. We gather here to address on the ways in which engineering science, in all its diverse forms, impact the global challenges we face today, from energy harvesting and conversion to advanced material for energy, from electronic and mechanical system to smart city, green computing, and artificial intelligence AI. Our discussion will revolve around these vital themes, and I'm confident that the insights shared here will have a lasting impact on our shared future. Over the last 2 centuries, energy needs have skyrocketed dramatically, especially because of the transportation and industry sectors. However, fossil fuels are halting and the reserves are limited. We know today that these resources are close to exhaustion and our societies are facing a major challenge, the energy crisis. Because of that, I believe this conference will be exciting for scholars and researchers to discuss, exchange, and share their knowledge, experience, and result finding to overcome this energy crisis problem. Ladies and gentlemen, I would like to extend my heartfelt appreciation to the organizing committee for their hard work and dedication in making this event possible. Their tireless effort have ensured a smooth and enriching conference for all of us. I also extend my heartfelt thanks to our distinguished invited speakers. The first one is Professor Kang Yoon Jo from University of Ulsan, South Korea. And the second one, Professor Josapat Tetuku Sri Sumantyo, PhD from Shiba University, Japan. And next, Professor Napa Rizal bin Nayan, University Tun Hussein, Malaysia. And then Professor Takahiko Miyazaki, Kyushu University, Japan. And next, Diplom Engineering Haznan Abimanyu, PhD from National Research and Innovation Agency, BRIN, Indonesia. And the last invited speaker from Universitas Mataram is Professor Dr. Engineering Igdi Pasak Sutawijaya, STMT. And also to all participants and all invited guests, panelists, and attendees who have traveled from near and far to participate in this conference. Through this conference, we hope we can not only exchange ideas, but also we can create global connections. I am confident that this 8th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering 2023 will be a resounding success. Thank you for your participation, and I wish you all a productive and enlightening conference. Finally, by hoping for God's blessing, let us open this conference officially by reciting Al-Basmalah together. Bismillahirrahmanirrahim. I wish you all a happy and successful conference. Thank you and God bless you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Akmaluddin, for the moving speech.
The excellent and our distinguished guests. Next, there will be an opening entertainment that will be delivered by the talented members of Warung Seni. To Warung Seni, the stage is yours. Thank you, Warung Seni, for the amazing performance.
Our next session will be speech by the Governor of Nusa Tenggara, Dr. Andes Haji Lalu Gita Aryadi MSI, which will be represented by Haji Wirawan Ahmad SSI MT, which will be moderated by Eko Prajoko STM Engineering PhD. To Eko Prajoko STM Engineering PhD, the stage is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera. Ladies and gentlemen, good morning all. I will very happy to sit here to will become to the head, the chairman of the session of the keynote speech in this. I would say to welcome all of you to the internal conference of 8 Icimece. This is hosted by the University of UNS. This is 11 Maret ya, Surakarta, and with the co-host of University of Mataram in this morning. So I will like to introduce myself. My name is Eko Prajoko. I am a lecturer from the Faculty of Engineering, University of Mataram. I will become the chairman of the keynote speech from Governor of Nusa Tenggara Barat, which is represented by the Mr. Haji Wirawan Ahmad, SSI MT. He is third assistant in the General Administration of the West Nusa Tenggara Province. So, good morning, Mr. Wirawan. I must just know you. I'm sorry. So for your speech, it is about 10 minutes. And then it will be answer question about 5 minutes. So Mr. Wirawan can speak in one bahasa or two bahasa, English and Indonesia. Please welcome. Yeah, this is your time. You can standing or you can. Yes, thank you very much.
Para pembalap berpacu di lintasan, mengendarai motor dengan semangat baja. Karena bahasa Inggris saya pas-pasan, mohon izin dengan bahasa Indonesia saja. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Yang saya hormati Rektor Universitas Mataram, yang saya hormati Rektor Universitas 11 Maret Surakarta, yang saya hormati Dekan Fakultas Teknik Universitas Mataram, para narasumber dan peserta International Conference yang saya banggakan. Burung terkukur hinggap di dahan, kicauannya merdu bersahut-sahutan. Mari bersyukur kepada Tuhan agar nikmatnya selalu ditambahkan. Jadi kita buat sedikit cair, karena saya tahu orang-orang teknik itu rata-rata serius. Dan kalau melihat jurusannya, teknik industri, teknik mesin, teknik elektro dan teknik kimia, semuanya adalah jurusan impian saya waktu saya masih pelajar dulu. Tapi takdirnya masuk di jurusan perencanaan pembangunan wilayah. Tapi bukan fakultas teknik, tetapi fakultas geografi. Yang pertama kami ingin ucapkan permohonan maaf dari Pak Gubernur karena beliau tidak bisa hadir pada acara ini. Sedianya beliau yang akan datang langsung, tetapi ada tugas di Jakarta yang tidak bisa ditinggal. Oleh karena itu, beliau mendelegasikan kepada kami untuk hadir pada acara ini. Ada dua hal yang ingin kami sampaikan pada forum ini. Yang pertama, kami ingin memberikan informasi selayang pandang tentang NTB, mulai dari kondisi geografik regionalnya, kemudian dari sisi regional challenge-nya, dan juga regional strategi yang hendak dikontribusikan oleh NTB dalam rangka mewujudkan Indonesia Emas 2045. Kemudian yang kedua, kami juga ingin menyampaikan secara singkat bagaimana ikhtiar NTB membangun ekosistem inovasi yang dihajatkan sebagai wadah kolaborasi multi pihak dalam rangka tadi menjawab permasalahan wilayah sekaligus juga mempertinggi atau memperkuat kualitas kebijakan dalam rangka kita mengimplementasikan strategi pembangunan regional yang tertuang dalam dokumen perencanaan jangka panjang, jangka menengah maupun jangka pendek. Yang pertama, kami ingin perkenalkan bahwa Provinsi NTB ini adalah provinsi kepulauan. Terdiri dari 2 pulau besar dan 400 lebih pulau-pulau kecil. Di antara pulau kecil itu ada 40 pulau yang berpenghuni dan ada 380 pulau yang tidak berpenghuni. Pulau Lombok dan Pulau Sumbawa itu memiliki tantangan regional yang berbeda. Kami informasikan sebelumnya bahwa Pulau Lombok ada 5 kabupaten kota, ada Kota Mataram, Lombok Barat, Lombok Tengah, Lombok Timur, dan Lombok Utara. Di Pulau Sumbawa ada Kabupaten Sumbawa Barat, Kabupaten Sumbawa, Kabupaten Dompu, Kabupaten Bima, dan juga Kota Bima. Pulau Lombok memang luasnya lebih kecil dibandingkan dengan Pulau Sumbawa, tetapi penduduknya jauh lebih besar. Implikasinya adalah kepadatan penduduk di Pulau Lombok lebih tinggi dibandingkan dengan Pulau Sumbawa. Permasalahan yang dominan muncul di Pulau Lombok karena tingkat kepadatan penduduk yang tinggi adalah permasalahan yang terkait dengan kualitas sumber daya manusia. IPM di Pulau Lombok relatif lebih rendah dibandingkan dengan IPM di Pulau Sumbawa. Tingkat kemiskinan di Pulau Lombok relatif lebih tinggi dibandingkan dengan tingkat kemiskinan di Pulau Sumbawa. Prevalensi stunting di Pulau Lombok relatif lebih tinggi dibandingkan dengan prevalensi stunting di Pulau Sumbawa. Tetapi untuk kondisi infrastruktur Pulau Lombok jauh lebih maju dibandingkan dengan Pulau Sumbawa. Pulau Sumbawa luasnya besar, tapi penduduknya sedikit, sehingga kepadatan penduduknya rendah. Tantangan yang paling dominan adalah minimnya kondisi infrastruktur. Sektor-sektor yang dominan di Pulau Lombok adalah sektor perdagangan, industri, dan jasa secara umum. Sementara di Pulau Sumbawa dominan pertanian dan pertambangan. Provinsi NTB sampai saat ini masih menghadapi tantangan regional yang cukup kompleks. Yang pertama, dari sisi ekonomi. Pertumbuhan ekonomi di NTB cenderung tidak inklusif. Didominasi oleh 2 sektor utama, yaitu sektor pertambangan dan sektor pertanian. Kontribusi sektor lain seperti industri, jasa, perdagangan itu masih sangat minim memberikan kontribusi terhadap pembentukan PDRB Provinsi NTB. Akibatnya adalah ketika terjadi gangguan pada 2 sektor utama tadi, pertambangan dan pertanian, maka pertumbuhan ekonomi NTB cenderung mengalami stagnasi. Bahkan pertumbuhan ekonomi triwulan 2 tahun 2023 itu pernah mencapai angka minus karena adanya penghentian kegiatan ekspor konsentrat di PT AMNT. Masalah yang kedua adalah masalah SDM. Angka IPM NTB itu masih lebih rendah dibandingkan dengan rata-rata IPM nasional. Kita masih mencatat angka 69, sekian. Kalau kita peringkat, kita masih berada di peringkat bawah, peringkat 29 dari 30 4 atau 38 provinsi saat ini. Kemudian kesejahteraan kita masih belum optimal. Tingkat kemiskinan kita masih tinggi. Kemudian stunting kita juga masih tinggi dan seterusnya. Kemudian masalah lain adalah kualitas lingkungan yang cenderung menurun. Kemudian tata kelola birokrasi yang belum optimal. Yang kelima berkaitan dengan proses pemenuhan target-target pembangunan berkelanjutan itu belum berjalan secara optimal. Dan yang terakhir adalah masih rendahnya indeks daya saing wilayah kita. Oleh karena itu, dalam rencana pembangunan daerah tahun 2024-2026, dokumen transisi yang menjadi rujukan bagi Gubernur NTB penjabat dalam penyelenggaraan pemerintahan pembangunan secara tegas, Provinsi NTB menetapkan strategi utama yaitu melakukan transformasi ekonomi. Apa itu transformasi ekonomi? Yaitu sebuah ikhtiar, sebuah kehendak untuk melakukan pergeseran secara sektoral dari PDRB yang ditopang oleh pertanian dan pertambangan ke arah sektor lain seperti sektor jasa, perdagangan, industri, tapi masih didukung oleh sektor pertanian. Nah, indikatornya adalah proporsi kontribusi sektor tadi terhadap pembentukan PDRB Provinsi NTB. Fakta datanya, proporsi kontribusi sektor pertanian, jasa, perdagangan, industri itu masih di bawah angka 49%. Jauh lebih rendah jika dibandingkan dengan Pulau Bali misalnya, sudah mencapai angka 57%. Itu adalah strategi yang pertama. Strategi yang kedua adalah kita ingin meningkatkan kualitas pembangunan manusia kita. Strategi yang ketiga adalah kita ingin meningkatkan kesejahteraan masyarakat kita dengan 3 indikator kinerja utama. Kita ingin agar angka kemiskinan menjadi rendah. Kemudian tingkat pendapatan per kapita masyarakat meningkat. Dan terakhir, koefisien Gininya juga turun, yang artinya terjadi pemerataan pendapatan antar kelompok masyarakat di Provinsi NTB. Itulah ikhtiar-ikhtiar yang kita lakukan dalam rangka memberikan kontribusi terhadap pencapaian Indonesia Emas 2045. Kami sadar bahwa cita-cita itu hanya bisa dilakukan dengan inovasi. Oleh karena itu, Bapak Ibu sekalian, Provinsi NTB termasuk provinsi yang pertama membentuk Badan Riset Inovasi Daerah yang menjadi cikal bakal lahirnya ekosistem inovasi di Provinsi Nusa Tenggara Barat. Sebuah ekosistem yang dihajatkan sebagai wadah kolaborasi antar pihak, baik masyarakat, perguruan tinggi, swasta, maupun juga media dan seterusnya untuk mengembangkan inovasi di Provinsi NTB. Ada beberapa hal yang dilakukan dalam ekosistem inovasi yang diwadahi oleh BRIDA. Yang pertama terkait dengan pengembangan sumber daya manusia. Kami mengirim putra-putri terbaik untuk menuntut ilmu yang dibiayai oleh APBD Provinsi NTB ke luar negeri melalui program beasiswa umum. Kami juga menjalin kemitraan dengan perguruan tinggi yang ada di NTB untuk memberikan beasiswa kepada anak-anak kita yang berprestasi melalui beasiswa stimulan unggulan. Kami juga bekerja sama dengan perguruan tinggi swasta membantu mereka dalam program beasiswa stimulan kerjasama. Rata-rata pilihan program studinya berkaitan dengan sains, teknologi, engineering, art, dan matematika. Kemudian di BRIDA juga dibangun program kemitraan. Program kemitraan ini dibagi 2. Kemitraan dalam bentuk inkubasi bisnis dan juga kemitraan dalam bentuk pengembangan usaha yang sudah matang dalam rangka transfer knowledge. Inkubasi bisnis kita arahkan kepada pemuda-pemudi NTB yang kira-kira punya ide bisnis dalam bentuk startup. Dan kita bantu mereka, kita berikan fasilitas gratis berupa kantor, kita bantu mereka koneksikan dengan pemilik modal, kita bantu pemasarannya dan seterusnya. Dan kemudian kemitraan dengan perusahaan-perusahaan yang sudah mapan, kita wujudkan dalam bentuk kerjasama di mana mereka bisa membuka tenan di Badan Riset Inovasi Daerah. Maka kami sedikit berbangga di Brida ada pabrik block solution, pabrik beton plastik satu-satunya di Asia Pasifik di mana sumber dayanya atau raw materialnya berupa sampah plastik. Di Brida juga ada mesin pirolisis yang merubah sampah plastik menjadi solar berkualitas tinggi dan ratusan produk permesinan yang dihasilkan oleh UMKM binaan Brida. Di Brida juga ada kegiatan kerjasama dengan perguruan tinggi melalui kolaborasi riset untuk melahirkan kebijakan yang lebih berkualitas yang berbasis pada evidence, riset, dan sains. Brida juga menjadi wadah bagi pelaksanaan kampus merdeka bekerjasama dengan UNRAM dan perguruan tinggi yang ada di NTB. Itulah ikhtiar-ikhtiar kami dalam rangka membangun ekosistem inovasi sekaligus untuk menjawab tantangan wilayahan yang masih dihadapi oleh Provinsi NTB sampai dengan saat ini. Demikian pengantar singkat sebagai welcome speak atau pemikiran pembuka bagi konferensi internasional ini. Kami berharap semoga pemikiran-pemikiran cerdas yang lahir dari konferensi ini dapat dikontribusikan untuk membangun daerah kami NTB pada khususnya dan juga Indonesia pada umumnya. Wallahul muwaffiq ila aqwamit thoriq. Assalamualaikum warahmatullahi wabarakatuh.
So thank you very much for Mr. Iram Ahmad giving the speech. So I would like to say translate some point of the speech. The first one is the speaker say about introduce about the policy of the West Nusa Tenggara province. It is consists of the island, two island, big island, and many small island. The big island is Lombok Island and Sumatra Island. And there is differences conditions of between these two islands. In Lombok Island, the west part, this is the infrastructure condition is already established condition compared with the infrastructure in the Maybe there is a question from Mr. Wiradi Ahmad. One question maybe, please welcome. Are there? No. Oh, yeah, yeah, yes, sir. Please, sir. Make satu pertanyaan, Mbak, ya, mic.
Thank you for this opportunity. I think this need collaboration.
Said the name.
Okay, my name is Nizam, Muhammad Nizam, coming from 11 Maret University. So I think this one is a good opportunity to make a collaboration between the state government and NTB and also university, especially for the innovation through green technology and sustainability in the future. So for example, this is opportunity to make the renewable energy and also to develop the what they call the green transportation, and so on, especially for the technology that related to the what the government need in to develop the local in the local potency, yeah, local potency, especially for example for the agriculture. And when we talk about this one, I think we have to sit together and to talk intensively to make your vision is become reality. Thank you.
No question, sir. I think
My question is one. The question is one. Is it possible to make this collaboration intensively, not only for the local university, I think national or international, to develop together with the new innovation to make the Nusa Tenggara Barat is one of the province that they have green technology and sustainability energy for the future. Thank you.
Thank you, Mr. Nizam.
Ya, saya pikir sangat terbuka peluang kerjasama antara Provinsi NTB dengan Universitas Negeri Surakarta. Karena kami sudah melakukan itu dengan perguruan tinggi lainnya, baik nasional maupun juga perguruan tinggi dari luar negeri. Kami bekerjasama dengan yang paling baru saat saya masih di Brida, bahkan dengan perguruan tinggi swasta, Universitas Bakri untuk mengembangkan teknologi maggot. Dan memang green technology atau juga economic circular adalah salah satu prioritas bidang yang betul-betul ingin dikembangkan di Provinsi Nusa Tenggara Barat. Dan tinggal kita buat MOU, kemudian kita tindak lanjuti dengan PKS dan beberapa kegiatan yang bisa segera kita konkretkan. Mudah-mudahan kerjasama itu bisa terrealisasi secepat mungkin. Dan cikal bakalnya sebenarnya pada saat saya menjadi kepala Brida, saya punya kolega di UNS dari fisika namanya Prof. Iwan. Kebetulan beliau itu berasal dari Provinsi NTB. Saya juga punya kolega punya kolega di sana, almarhum Dr. Yasin Yusuf, dan juga beberapa perbincangan awalnya sudah terjadi, tinggal kita pilih bidang mana kira-kira bisa segera kita konkretkan kerjasamanya. Demikian, Prof.
Thank you very much. So the answer is possible, Mr. To make collaboration even in local university, also national, or even overseas. So in here, so maybe we have also opportunity working together with from Malaysia, from Korea, something like that, because the person is attending here. So I think time is finished. So please give applause to Mr. Wirawan Ahmad. Thank you very much. I hope that you will get a benefit from this presentation. So I close the first session with Alhamdulillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. I return to the MC the time.
What an amazing speech by the representation of the Governor of West Nusa Tenggara. And thank you, Eko Prajoko STM Engineering PhD, for being an amazing moderator. Before leaving the stage, we would like to give a memento that will be given by the moderator. The moderator will give a memento for the speaker on the stage. Now let's move on to our next agenda, which is the photo session. To all the invited guests, please join us to the front of the stage for the photo session.
All right, thank you for your participations. Ladies and gentlemen, you may be seated and we'll continue our agenda. While we prepare the panel session, we will also be having a coffee break. So to all the participants, please feel free to go to the designated area to enjoy your refreshments because the panel session will be started shortly. Please enjoy the coffee break. Thank you.
Ladies and gentlemen, now we are entering the panel session. The panel session will be divided by 3 sessions, and each session will be brought by 2 keynote speakers and a moderator. Without wasting any time, let's start our first panel session, which will be brought by Professor Josafat Tetuko and Professor Nafarizal bin Nayan. The moderator for this panel session is Insinyur Ferry Adrianto, PhD, ASEAN Engineering. To Ferry Adrianto, the stage is yours.
Bismillah. Good morning. Assalamualaikum warahmatullahi wabarakatuh. Welcome to the keynote session of the Icimece 2023. My name is Ferry Adrianto from the Department of Electrical Engineering, 11 Maret University. And I am the moderator for this session. We will the hearing keynote presentation from Professor Josafat Tetuko Sri Sumandio, PhD, from Center for Environmental Remote Sensing, Shiba University, Japan, and Professor Dr. Engineering Nafarizal bin Nayan from Faculty of Electrical and Electronic Engineering, University Tun Hussein On, Malaysia. Prof. Josafat and Prof. Nafarizal, please come to the stage. Thank you, Prof. Jos, Prof. Nafa. How are you today, Prof. Jos, Prof. Nafa? Before we get started, I wanted to take a few minutes for the introduce of the speaker. The first keynote speaker is Professor Josafat Tetuko Sri Sumantio, PhD. He is a professor at Center for Environmental Remote Sensing, Shiba University, Japan. Prof. Josafat is IEEE senior members, was born in Bandung, Indonesia in 1970. He received a Bachelor of Engineering and Master of Engineering degrees in Electrical and Computer Engineering from Kanazawa University, Japan in 1995 and 1997 respectively, and the Doctor of Engineering, Doctor of Philosophy degree in Artificial System Sciences from Shiba University, Japan in 2002. Sorry. He is a full professor from 2013 to now. He is also a faculty member at the Department of Electrical Engineering, University of 11 Maret, Indonesia. He is a member of international and domestic organization, reviewer of journal and organization. He also promoted many students from around the world, and as a visiting lecturer, visiting professor in many university. Also, he is head of the Department of Environmental Remote Sensing and head of Division of Earth Environmental Sciences, Shiba University, from 1st April 2019 to 31 March 2020, and 1 April 2022 to 30 March 2033. 20. Yeah. His main interests are theoretical scattering microwave analysis and application in the microwave radar remote sensing, especially in synthetic aperture radar (SAR) and subsurface radar, including INSAR, DINSAR, PH INSAR, and polarimetric SAR analysis and design of antenna for mobile satellite communication and microwave sensor. Development of microwave sensor, including various polarized SAR sensor for UAV, drone, aircraft, high altitude platform system, and microsatellite development. He managed Josapat Microwave Remote Sensing Laboratory, Center for Environmental Remote Sensing, Shiba University, Japan, since 2005. He managed also several student and research staff exchange between Japan and overseas institutions. He also a honorary professor, visiting professor, and adjunct professor of the University of Indonesia and Institut Teknologi Bandung, Jao University Korea, and consular of Satohyo International Scholarship Foundation and Atsumi International Scholarship Foundation, Japan, to promote exchange students between Japan and Southeast Asia and South Asia. And also advisor of Senior High School of Pradipta Dinkantara Surakarta for Student Excellence Student Program and Exchange Program with Japan Academic Institution. Prof. Josapat, member IEEE, ICICE, JSPRS, and RSSG. He is also recipient of many awards and research grants related to his study and research. And he published more than 12 books and 1,000 papers in journal, conference, invited talk, and report. He established on symposium in microsatellite for remote sensing, and also he managed conference on synthetic aperture radar 2021 and APSAR 2023 recently in Bali, Indonesia. More than 300 invited talk and lecturer related of synthetic aperture radar and application. He is also co-reader and of the working remote sensing instrumentation and technology for UAV of IEEE GRSS Technician Committee and or on instrumentation and future technology. He is an associate editor of IEEE Geoscience and Remote Sensing Lecture, signed March 2021, and IEEE Antenna, Wireless and Propagation Letters, signed January 2023. The second presenter is Professor Dr. Nafa Rizal Binayan. Prof. Nafa is a professor on plasma nanoprocessing and diagnostic at University Tun Hussein on Malaysia. He graduated his Bachelor of Engineering, Master of Engineering, and Doctor of Engineering degree at Plasma Nanotechnology Center of Nagoya University, Japan in 2003, 2005, and 2008 respectively. His permanent position as at Department of Electronic Engineering, Faculty of Electrical Electronic Engineering, University of Tun Hussein on. He did of Min SRC at UTSM in 2009 until 2013 and 2016 until 2018. He had also Institute for Integrated Engineering in 2019 until 2022. And currently he holds the position of Director at Research Management Center RMC in UTSM. In 2019, he received Nagoya University Award for contribution for international exchange in recognition of his endeavor to establish the NUL Malaysia branch. He is also active as the executive committee member of the IEEE Electron Device Society Malaysia, IEEE Sensor and Nanotechnology Council Malaysia Joint Chapter, and Malaysia Nanotechnology Association. He was also a member of Young Scientists Network Academy Science Malaysia. He has been engaged in the research of the characterization and designing of low temperature plasma system using vacuum and non-vacuum method. His research of interest on plasma diagnostic, plasma processing, and thin film deposition. As project leader, he secured 1.37 million ringgit Malaysia in total from government and industry Research Fund, and from 2013 to 2015, he visited Quantum Science Engineering Hokkaido University as foreign researcher for novel solar cell thin film fabrication using sputtering technique and synthesis and diagnostic of metal nanoparticle. To date, he is the author and co-author for more than 80 ICI journal paper, 130 review journal paper, and more than 200 conference paper for international conference. He has delivered for more than 15 international keynote and invited talk. Let us a big round again of applause for two presenter. Thank you. This presentation time for each keynote speaker is 20 minutes for talk. The time for Q&A for two speaker 18 minutes and 2 minutes for moderator and keynote speaker switch. For the Q&A, the end discussion, please ask the question by raising the hand, open the mic for participation in online, or write the question by using chat or the Zoom menu. In this session, Prof. Josapat is the first presenter, and then Prof. Navarizal. Prof. Josapat will present with the title, The Development of Advanced Microwave Remote Sensor for Disaster and Environmental Monitoring. And Prof. Navarizal will present of the presentation with the title of Plasma Processing for Industry Revolution 4.0. Ladies and gentlemen, please welcome Prof. Josapat, Sri Sumantio, and Prof. Navarizal. The floor is yours.
Thank you very much to Dr. Ferry, yes, for the introduction, yeah, and thanks to the Governor of Nusa Tenggara Barat, yeah, and also the President of the UNRAM and also the President of the UNS, and here some of our colleges students, yeah. Okay, as the introduction, my name is Yosafat Tutuko Sri Sumantio from the Chiba University Center for Environmental Remote Sensing, and also from the Department of Electrical Engineering, Universitas 11 Maret. Okay, sorry, this is how to use this one. Oh, okay, could you move to first slide? Yeah, okay. No, the title. Yeah. Next, yeah. Okay. Today, I want to introduce what we developed in my laboratory. My laboratory is Josaphat Microwave Remote Sensing Laboratory, or JMRSL. Yeah, and the title of my presentation, like shown here, in the development of advanced microwave remote sensing sensor for the disaster and environmental monitoring. Yeah, and it is some of my product in our laboratory. Yes, we developed the platform, especially the unmanned aerial vehicle, when the wingspan is 6 meters, when the payload is 30 kilogram. And now we developed 28 meter, with the payload is almost same, 30 kilogram. For the mission is one mission is for 6 months. Yes, continuously. And yes, we developed the sensor itself is the synthetic aperture radar, or SAR. Yeah, and especially the circularly polarized synthetic aperture radar, or CPSAR. It is my patents and our brand. Yeah, and we already put on the drone itself. Yes, from the L-band, and also from the CN-235 aircraft here. It is from the C-band. Yeah. And from the Boeing 737, it is X-band, and for it is my microsatellite. Yeah, it is the L-band and the C-band. Yeah. Okay, next. Yeah. Next slide. Yeah. The background of this research is, especially Indonesia and Japan, it is almost same environment. Yeah, we have various of the disaster. Yeah, especially in the earthquake. Almost every day we have the earthquake. Yeah, I think Indonesia also same. Yeah, and the volcanic eruption. Yeah, it is all. Indonesia have about 129 active volcano. And Japan, we also have more than 30 volcano. Yeah, and almost every day is have some eruption that we need to observe 24 hour. Yeah, so in this case, we need the sensor that we can observe even in the night time, and also we need to penetrate the cloud, and also in the haze, and sometimes also in the volcanic ash. So in this case, I think it's the one sensor is called the synthetic aperture radar. It is I think the matching the match sensor. So in this case, we develop. You can see here. Yes, we develop the synthetic aperture radar, or SAR. Yes, here, and for the unmanned aerial vehicle, aircraft, and also the high altitude platform that we can operate when the altitude is about 15 to 25 kilometer. Yeah, and we also develop our own micro satellite when the payload is 150 kilogram. This one is, of course, we also develop. It's not just for the Earth observation. We also develop the sensor to observe the moon and also the Mars. Yeah, and one of the staff of the UNS, yes, Pak Subuh, now he developed the antenna using the material from the moon. Yes, I hope in the future is we can also make some some industrial activity on the moon. Yes, in the future. Okay, it is all is our product. Yes. The sensor from the Boeing 737, yes, and this one is from the CN235, and from the Cessna, and also for our drone, and also for our microsatellite. Okay, next. Yes, it is the concept of the CPSAR. Yes, you can transmit just one. Yes, right-handed or RRCP, yeah, right-handed circular polarization, or left-handed circular polarization. And the wave will scattered by the object. It depend on the shape, yes, and the roughness, and also the orientation of the tilted, angle of the object, and the characteristic of the material itself, on the size of the material, and the wave will scatter to be the left-handed and right-handed, and you can get both the data, and then you can process for the new of the polarimetric synthetic aperture radar. And using this polarimetric synthetic aperture radar on the pulsar, you can get many type of the information based on the circular polarization. And it is my patents in Japan. Yes, of course, I also covered some country in the overseas. And you can see this one. It is optic. Yes, if you use optic, as the wave, it means the scattered of the sunlight will cannot penetrate the cloud. Yeah, but if you use my sensor, it is PSAR. You can penetrate the the cloud, and you can get the data. The picture is very good. It's not just can penetrate the cloud or haze on the on the mist. Yes, but my sensor also can be operated in the night time. So 24 hours, anytime you can get the data of the area that you want to observe. Yeah. Okay. Yeah. Because we cannot wait the disaster. Yeah. The disaster anytime. Yeah. Okay. Next slide. Yes, it is in the roadmap in my laboratory, Josaphat laboratory. Yeah, we already finished develop some sensor that it is for the the ground, and also for the aircraft. Yeah, and next now we want to realize for the hubs. Yeah, I hope the end of this year or next year. Yes, we want to fly in Indonesia using this hubs. Yeah. And okay, and sorry, to observe the global. Yes, globally is using the microsatellite. Yeah, In our plan is we want to launch at least is 5, yes, 5 microsatellites, so we can observe any point on the Earth is every day. Yeah, and using the hubs, you can get video data of the synthetic aperture radar, or in every second you can get 24 images. Yeah, I think it is also, I hope, the new technique in the world. Yeah. Okay, next. Yeah. Yeah, it is the product that we already made in our laboratory. Yes, for this aircraft and also for the, for the unmanned aerial vehicle, and for the aircraft. This, the drone, yeah, or unmanned aerial vehicle. This one is hybrid drone. It is VTOL with the 2-hour mission. Yeah. And this one is for the this one is for the 4-hour, and this one is for the 2-hour. Yeah, and this one in the hubs. This one is we can fly for 6 months. Yes, continuously. Yes, I think it's more efficient using the drone compared to the satellite. Yeah, and from the detail, as you can read my book, it is just published last April. Yeah, it is airborne circularly polarized synthetic aperture radar that published by the CRC Press and the IEEE. You can get, it's very detailed data, yes, including the theory, yeah, of the circular polarized propagation and the scattering, and also the how to design the system itself, and then the hardware itself is very detailed, and also how to integrate it, and also to test, yes, the ground test or inside the unequipped chamber, and also for the flight, how to install on the aircraft, and also how to operate, on the system itself. And finally, upon the image processing, you can find also the code, yeah, in MATLAB. It's very detailed, yeah. And also finally the application, yeah. You can buy one book, yes, and you can buy this one is just 200. Pound sterling. Yeah, I think it's very cheap. Yeah, very cheap, and you can get all of my experience, all of my head, content is in this book. Yeah. Okay. Next. Yes. Okay. And another books. Yes. For the microsatellite SAR. Yes. You can find in this radar remote sensing book. Yes. It is chapter. I think chapter 19. Yeah. And also for the drone. Yeah. Unmanned aerial vehicle. Onboard synthetic aperture radar in this book. Yes, it is chapter 15. Yeah. Okay, it is the example of the circularly polarized synthetic aperture radar image that we got at the southern part of the Makassar. Yeah, it's very detailed when the resolution is 37.5 centimeter. Of course, we can, increase the resolution. Yes, to be 5 centimeter. So you can get the map of the scale is 1 to around 1,000. Yes. 5,000 scale. Yes. Now the BIG or the BPN of Indonesian government need this map. Yeah. Okay. Next. Okay. Yeah. It in the mission. You can use the sensor for many missions. Yeah. Of course, we developed this one is for the disaster monitoring and also for the environmental monitoring. But we can also use for the natural resources, observation. Yeah, it is now we work with one of institution in Indonesia. Yes, for the fishery and maritime observation, and also the Pertamina. Yes, now we developed the sensor to observe the oil spill. Yes, at the northern part of the Jakarta. Yes, we have some platform at the Kepulauan Seribu. We install this system. Yeah. Okay. And the other one is for the home security and anti-terrorism mission, and also the infrastructure monitoring. Yeah. Because we can get the data is very precise, and you can use the information of the face. Yeah. And you can get every year is, for example, 1 centimeter change. Yeah. You can observe. Yeah. It is example that we already done for the Malaysian government. We observe the Malaysian highway, especially the east-west highway, yeah, from Kuala Lumpur to the Kota Baru. We observe, annually, and we can get which part of the East-West Highway will the land deform, and which area the landslide will happen. Yeah, we can predict. Yeah, and if some of the red part, this one is the land is moved every year is about 3 centimeter to 6 centimeter. You can calculate in for example 5 years. Yes, it's 15 centimeter move. It means the building is 15 centimeter move. It means the wall will crack. Yes, and some infrastructure will destroy. So we observe especially for the landslide. Yeah, to observe and estimate and also predict which area the landslide will happen. Yeah. Okay. Next. Yes, compared to another synthetic aperture radar that already operated by some, aerospace agency like JAXA of Japan, yes, and then NASA, yes, and also the DLR of the Germany, and so on. Yeah, all is linear polarization. Yes, you can get just the information of horizontal and vertical. But my sensor, yes, that already put on the CN235, this one circular polarization. You can get all of the angle, yes, 360 degree, all of the angle, you can get the data. Yeah, it means more various data using my circularly polarized synthetic aperture radar. So, but it is this technology is very difficult. Yes, how to realize the circular, because the antenna must circular, and also the image processing also circular polarization. Yeah, but we already done all, and you can find in my books. You can just continue our research. Yeah. Okay, next. Yes, it's some of our mission using the Cessna that it is with my student. Yes, actually my student is from many countries, from Germany, Japan, Indonesia, of course. Yes, and also from Malaysia and Pakistan. Yes, India. Yes, yes, Brazil. Yes, I think it's many. Yeah. Maybe more than 200 students already I graduated from my laboratory or Josaphat laboratory. Yeah. Okay, next. Yes, we are not just the the system on the theory itself. We also develop some material we call as the polymaterial. It is very light, yes, like the polymer, gabus in Indonesia. Yeah, it is we call it the polyester. Yeah, and polystyrene, yeah, a styrofoam, yeah, and then we use our polymaterial, and the strengthness is like the steel. It's very strong, yeah, and we have this patent, and now this patent is used by some company in Japan, and we got some commission for this one. Yeah, I hope we can also develop this one in Indonesia in the near future. Yeah. Okay, next. Yeah, it is the antenna that developed by our student. It is a circularly polarized with the bandwidth is 400 megahertz. Yeah, and installed in CN235 NX. Yeah. Yeah, it is our CPSR system, C-band, that installed in the CN235 aircraft. And now we discuss with in Indonesia, yet we want to realize this one is more. Yes, I hope we can operate to observe Indonesia anytime, because we have many disasters. Yeah, and I think it's with the resolution is 37.5, and I hope more increase. Yeah, about 10 centimeter. You can get more precise, and including the building. Yes, which building is will destroy, or we can find the people that already impacted by the disaster itself. Yeah. Okay. Oh, sorry. How many minutes? Yeah. 3 minutes. Okay. Yeah. Next. Yeah. Okay. Yes. We made the experiment. Yes. It is with and without the radon. Yes. Using the corner reflector, and it is very nice. It's just some 0.4 dB of the loss. Sorry. Next. Yeah. Yes, it is the image, the first image of the circularly polarized. Yes, it's very clear. It is in the Lanut Hasanuddin. Yeah, It is without the filtering, and you can get the data is very nice. And if you zoom up, is more you can find some of the information inside the building of this object. Yeah. It is the optical with the cloud, and using the synthetic aperture radar is without the cloud. Yeah. Okay, next. Yeah. Yes, if you zoom up, it's more zoom up, zoom out, and you can get more, very clear image of the object. Yeah. Okay, next. Okay, this full polarization. If full polarization, the cross polarization is more strong. Yeah, right-handed and left-handed combination, and LLRR, it is co-polarization is more less, scattering. It is opposite to the characteristic of the linear polarization. Okay, next. Yes, it is more clear. If you zoom up, it's like this one. You can find, you can imagine the shape of the tree itself. Now, one of my students is using this image. We can, extract just the information of the tree, and you can, estimate the shape of the every tree. Yeah. I hope in the future you can estimate, the carbon. Yeah, and you can buy, this information, and we can sell this information, and you can use for the carbon trade in the future. Yeah. Okay, next. Yes. Okay, for the ship detection. Yeah. Next. Oh, it's not so clear. Yeah. Okay, this also the ship detection too. Yeah. And from the mangrove, we observe from the mangrove area. And also to detect the we call it, what is the karamba, yeah, karamba, yeah. Because last time is I used this one is for the marine observation and fishery. Yeah. Next. Yeah. Okay, this is for the mangrove, mangrove area at the Pangkajene area. Yeah. Next. Yes, finally, it is for the satellite. Yes, we spent some of billion US dollar. Yes, to develop this our microsatellite, and especially this one is the antenna we developed using the gold. Yeah, and we spent 1.5 million US dollar just for the prototype. Yeah, and yes, it's very good performance of this one, and one of the company and Japan used this design. Yeah. Okay, my student is this one is from Pakistan, Japan, and now it's Brin. Yes, before in the Lapan, it's two guys. Yes, and Katya Sang is from Brazil and now work at the European Space Agency, and Chua Sang, yes, now is working at Xiamen University. Yeah. If you want to enroll to my laboratory, we are welcome, and we have many, program, including the double degree program with 5 university in Indonesia. I hope with the UNS also we can create the double degree program, yeah, and then you can learn at UNS, but you can also learn in my laboratory, yeah, and you can get 2 certificates, yes, for your graduation. Okay, finally. Last this one, yes, it in the system is very compact. Just totally for the SAR itself, it's just 50 kilogram. Yeah, compare the conventional one is 1 ton or 2 ton. Yes, this one is just 50 kilogram. Yeah. Okay, I think the last one is the close slide. Yeah. Thank you very much. If you want to contact me, if you can call to this mail address to Chiba University, or my email address at Universitas 11 Maret. Yeah. Thank you very much, and I give back to time to Pak Ferry. Yeah. Thank you.
Thank you, Prof. The next presenter is Professor Nafarizal.
Okay, thank you very much, Dr. Ferry. Thank you, the organizing committee from UNS and UC Mataram. So my name is Nafa. I am from University Tun Usin of Malaysia. Just allow me to share something about my university and also some research that we done at the university. And Dr. Ferry was with us at UTHM several years ago. He know a lot about our facility, and I hope we can share some of the facility with you guys here. So the title of my talk will be on the plasma process for the Industrial Revolution. And I am a member of several IEEE organization in Malaysia, and also alumni university of Nagoya University. And we also have a Malaysian Nanotechnology Association in Malaysia. And this is how we collaborate and try to coordinate research among us. Next. So since I have quite a number of slides, so I'll have to go fast. So next, please. So next. Oh, I can control the slide. I can control using this one. Okay, this is just about where is our university. If you go to previous slide, please. So our university is located in the southern region of Malaysia, very close to Singapore, and this is about 2 hours by car from Kuala Lumpur. And we have 3 main campus in this Johor state, which is on the Parit Rajan main campus and Tanjung Labu campus and the Pago branch campus. The land area is like 500 acre. Next. So this is some figures about our students. We have like total almost 18,000 students, and our postgraduate is like this is about 900 master and 700 PhD students. 13,000 of the undergraduate students. Most of the foreign students come from UAE, Indonesia, Yemen, Pakistan, and Somalia. Next. So for the research ecosystem, what we have in the university is that we create a focus group, a research focus group in each faculty. So in each faculty, we have several numbers of research focus group. The total number of focus group is 121, and we have on top of the focus group we have the center of research, so where we gather some of the focus group and they become a center of research, a bigger group, and we have a 28 center of research. Once the center of research become more excellent, they will go out from the faculty, they will form their own center of excellence. So at our university, we have 5 center of excellence. They focus on the soft soil, which is on research, the electromagnetic capability, which is EM center, micro and nanotechnology center, where I belong, is main SRC, and we have advanced manufacturing and material center, and also micropollutant research center, so MPRC. So after we have this COE, we also have an institute where this institute will also govern some of the research activity in the universities. Next. So this is our research building. So the main SRC, Micro and Nanotechnology Center. So one of the area in this building is belong to my lab. So our group lab is called a Plasma Processing Research Lab. Next. So some infographic about the facility that we have in the lab. So we have the facilities like the electron microscopes, atomic force microscope, Raman spectrometer, X-ray, XRD, magnetron sputtering, ion etching, etc. So these are all the characterization tools that we have in the lab. And the facility that we have is more than 15 million ringgit, and we share with all the research entities in the universities. Okay, next. So what we try to aim is we want to have the facility all under one roof, so that so the students, the lecturer, the researcher, they have just to stay in the same building, and then can do all the process and also characterization in the same buildings. Next. So this is a member of my research lab. So not a big number, but we can work as well, as long as we can do some research. So next. So the reason we have this micro and nanotechnology center is actually to support this ecosystem in Malaysia. So this is we call as a Silicon Malaysia. I think everybody know about the Silicon Valley in the state. So in Malaysia we have also this kind of a Silicon Malaysia, where all the giant of the semiconductor industry, they are gathered in some area in Malaysia. Mostly is in the northern area in the Penang Island. So we have a big giant company like Intel, Osram, or AMD. So these are all the semiconductor industry in Malaysia. So to support this semiconductor industry, we need to produce a good of talents. So that's why how we have this micro and nanotechnology center at our universities. So next. So those number was quite very recent. This 50th years of anniversary of semiconductor in Malaysia, it actually started with this 8 samurai in Malaysia. So we call it as 8 samurai. So these are the numbers of company that started 50 years back, before just after the Malaysian Merdeka. So then we have these 8 company that start the semiconductor industry, and then it grew until right now. So next. So we can also see that the number of manufacturing in the semiconductor industry, this is the sale of the chips grows year by year. We can see after the pandemic, we can see so many more gadgets, so many electronic products out there in the market, and a lot of boom in the semiconductor industry. So we can see even in Malaysia, actually there's a lot of new investment coming into Malaysia. For example, like Infineon investing 8 billion, Intel investing 30 billion, Nexperia 1.6 billion, AT&S, some Australia company investing 4.8 billion. So this kind of investment is coming to create a semiconductor ecosystem in Malaysia. So next. So the future technology need a lot of microprocessor. Next. And to support this semiconductor industry microprocessor, so all this semiconductor industry need to have a very efficient, a very safety, a very reliable and good lifetime of their manufacturing process. So that's how we go to the next. That's how we need the IR 4.0 actually. Go next. So in semiconductor manufacturing process, there is a lot of process, hundred of process actually. So these are some of the process that we would like to focus. So you start with a wafer, and then this wafer will go through all the process until it become you do the packaging, and then you do the finishing. Next. In our lab, we only try to focus on this plasma process technology, which is focused on the thin film deposition, etching process, and also the surface modification and activation. Next. So what is plasma actually? Next. So I think everybody know about the solid, liquid and gas. So we have an ice cube. We heat the ice cube, it become water. We heat the water, it become the vapor. And if we heat a vapor, what it become? It become a plasma. So the next. So this is a fourth state of matter that we call as a plasma. Next. So we can see the aurora also is a plasma in the nature. Next. So we can also see the pendafloor lamp, and at home this is also another simple type of plasma that we have at home. Next. So why plasma is important? This is a simple classical benefit of plasma. to show that if you do the process using a gas only, actually this is the graph to show the etching process, a silicon etching process. So if you use only a gas only, you can see the numbers is very low, the etching rate is very low. But if we combine gas and also the plasma at the middle, you can see the etching rate is increasing very drastically. So this is to show that the importance of plasma and combined with the gas, so that we can have a much faster etching process in the semiconductor industry. Next. So in the previous years, people work on in plasma or the device. They try to control the one that they call a power supply, the pressure, the chamber inside the chamber, the pressure. What is the gas flow that we use for the process? What will be the brand of the vacuum chamber? So this is old school try and error technique. So this is not very good. But in a smart semiconductor manufacturing, we need a very high-end technique. If you go next. So what we want to do is that they can actually do nano processing, they call it. So instead of do try and error, we want to understand what inside the plasma, what is the ion density inside the plasma, what is the plasma temperature, what is the velocity, what is the energy distribution inside the plasma, so that we can relate that to the film that we fabricate. So this is what we call as a smart semiconductor manufacturing. Next. So there are several roadmaps actually have been published. You can see in the article, for example, this is in 2012. So they have published this kind of article to show how the process of plasma that can help the semiconductor industry. If you go next. So then again in 2012, they published another roadmap for the plasma technology. What will be the future of plasma, what type of new plasma that you can have, what kind of plasma source that you can create. So, and also some characteristic of the plasma. So next. So this is another review article also to explain about how the plasma can be used for the another application. You can see next. So this just a cartoon to show that this plasma can actually use for various kind of application. It can be used for health care, medical hygiene, do the sterilization. It can do the cleaning, surface modification. It can use for the environmental and agriculture application, aerospace and automotive. They can do the hard coating and soft coating as well. It can be used for the opticals coating as well. So a lot of application that can be used. Next. So quite very recently in 2022, there is another roadmap on the plasma to show how we can use the low pressure or low temperature plasma science for a new application. Next. So the application that has been used is actually focused on the agriculture. For example, you can see on the left, actually we try to do the enhance the properties of the seeds to make sure that the plant can grow faster. So you can see on the left they expose the plasma to the seeds and then you can have a better growth. And then on the right you can see how the plasma can use for the pollution control to decompose all the things that cannot be used, cannot be decomposed using the conventional technique. So they can use a thermal plasma for this application. Next. So these are some examples of the plasma that we have in our lab. So where we do the deposition of the thin film. So next. So this thin film actually we use it to fabricate a dye-sensitized solar cell. So this is the example of the solar cell that we fabricate. We go next. And then we characterize the efficiency of the solar cell. So we get some result, which is not very bad. So then next. And we also try to fabricate our own plasma jet, which is much more simpler, not using a vacuum chamber. You don't need a very high-end or sophisticated equipment. You just need a power supply, a gas flow, and then you can create your own plasma jet. So then this plasma, go next. We expose this plasma jet to kill the bacteria using E. coli bacteria, so then we can prove it that it can be used for the E. coli inactivation. Next. So this is some example to show that of inactivation of the bacteria. Next. Next. Okay, next. Okay, so just to show that we can do it in less than a minute. Next. So there's also some article published in the review paper to show that how this plasma can use for the treatment of the tissue. So next. And it can also use to do the whitening on the teeth. Okay, next. So that in the future you don't need a dental drill or needle that is very pain. So then in the future we can have a painless technique to do the whitening of all your teeth. Okay, next. This is good for somebody who like a coffee, right? Next. So my take-home note is that first. Next. So the novel plasma process is a high demand in the future semiconductor industry. Next. And a new application of plasma technology are necessary for the future needs in healthcare, food, and waste processing. Next. So I would like to offer this kind of a service as well, where we do the characterization of electron microscopes, and our lab is ISO standard 70025. Next. And that's all. Thank you.
Thank you very much. Okay, thank you, Prof. Josaphat and Prof. Nafa Rizal. The second session is Q&A and discussion. Please raise hand, maybe. We have 18 minutes for Q&A and discussion. Any question? Please. Okay, once. Okay. Maybe direct to us and please introduce yourself.
Test.
And okay.
Thank you very much. I'm Roni Zakaria from UNS Solo. I have two questions to Professor Josaphat. The first, it means that the CV SAR bring or flight by aeroplane and maybe drone, something like that. It's possible that the product insert to the satellite that orbitally in Earth, I mean by maybe polar or equatorial. The second, and two, how many maximum resolution from the capturing the image? I mean, if we compare with the existing product, example for the optical technology, for the maybe Kongsberg or something like that, how the comparison for the resolution? Okay, thank you.
Okay.
Maybe I answer. Yeah.
To answer.
First is, the question is about the orbit, you mean? Yeah. Okay. For the microsatellite SAR, we can use for the polar orbit and also for the equator. Yeah. And okay, yes. Another information is, yeah, we developed a 150 kilogram, yeah, microsatellite. Yeah. It is our target. Yeah. And then the next one, the comparison. Yeah. Between the
maximum resolution between the.
Okay. Okay. Right now, for the C-band CPSAR, yeah, we have the resolution is 37.5 centimeter. Yeah. With the bandwidth is 400 megahertz. And of course, if you compare with the another C-band, is I think our system is I think the best one, yeah, because bandwidth 400. And now we also developed the antenna and the system with the bandwidth more larger. Yes, one of my students is now is already close to 1 gigahertz. Yeah, it means about twice or 3 times of the resolution you can get. It means you can get 15 centimeter. Yes, this is more better. Yeah, and if we compare with the H band or K band, we also developed the K band right now. Yeah, I hope on the K band is more small. Yeah. Right now, C band SAR is totally with the battery is about 100 kilogram. Yeah. On the K band, no, is I hope less than 5 kilogram. 5 kilograms, so we can put on the small drone, yes, or unmanned aerial vehicle. Yeah, this is more, I think, more a lot application in the future. Yeah. Okay, can answer your.
Okay, it means that the best resolution can achieve in C band.
Yeah.
Right now.
Yeah.
And for developing, maybe upgrade to K band or some.
No, we already developed the K band.
K band.
Yeah. I hope yes. Next month is already we have the system for the K band. Yeah, and the K band antenna is already developed my PhD student. Yeah, and from the system is next month we'll finish and we can integrate. And I hope within this year is we can establish for the C band synthetic aperture radar and also the antenna to observe the oil spill. Yeah, and we want to put on the platform of the Pertamina. Yeah, at Kepulauan Seribu.
Okay, thank you very much.
Okay. Thank you, Pak Roni. Maybe the next question, please.
You can ask in Bahasa. Okay, no problem. You have problem with the English.
Maybe in Zoom online. Okay. Pak Anwar.
Good afternoon. My name is Miftahul Anwar from 11 Maret University. I'm interested in plasma processing or plasma application without any damage from Prof. Nafa. What is the characteristic of voltage and current for any damage? Because we know that the plasma is usually have a high voltage or high current, and that is very dangerous for our health. Yes, that's it. Thank you.
Thank you, Pak. The voltage that we apply for our device is very high. Yes, up to kilovolts, sinusoidal, and the current is like several ampere. And it's even though we supply a very high voltage, that current actually applied to the electrodes. So the electrode is very dangerous. But when we create a plasma plume, you can see the long longitudinal plasma that we create. The afterglow is not very high voltage. There is no voltage applied over there. Even though if we touch it, it's not a problem. And if we did some tests, what is the temperature in the afterglow of the plasma? So it's almost to the room temperature, which is okay. So, but still, of course, I think there is not need to create some safety precursor caution because we are using a high voltage. But nowadays, I think there is already there in the market the one that plasma that can expose to the skin, and they do the treatment on the skin and also the teeth. So meaning that it's already safe for the after the clinical test.
Okay. Sina, Pak Anwar. Okay. Maybe we have 5 minutes left. Do you have any question? Prof. Jos, Prof. Nafa, I have question regarding the remote sensing. We have two types, microwave and radar. Based on disadvantages and advantages, how do you think about the trade-off between microwave and radar, and also about the cost?
Maybe I can revise. Yes. In my remote sensing is we have commonly or generally is the optic and the microwave. Yeah. The optic is like the camera. Yes, it is used with the source is from the light, including lidar and also the sun. Yes, sunlight. This is the optical remote sensing, and microwave remote sensing is including the synthetic aperture radar and also use the we call in the GNSS or the GPS. Yes, GPS wave scattered, and then we can get GPS reflectometer. Yes, and also we can use directly of the GPS. We call in the GPS radio occultation or RO. Yeah, optic and also the microwave.
How about the cost between microwave and the optic? Is
the cost?
The cost, yeah.
Okay, yes. On the cost itself is depend on the resolution and the accuracy. For the good resolution from the optic means you must keep the lens. The lens as big as possible, and also how to keep the lens is low noise. It means you must control the surface temperature of the lens itself. For example, if we observe the Earth, it means if facing to the sun, it is very high temperature. I mean about 100 degrees. In this case, you need the what is cooler. But if you observe in the back of the Earth, it means minus 50 degrees. You need the heater itself. How to keep the surface of the lens is on the normal temperature. For example, 25 degrees Celsius. If we use the material from the Earth, it's like this. Now, why we also develop some material from the moon and also from the another planet, like now Pak Subuh is doing this one. And for the microwave, in the case of microwave, is how to increase the resolution is based on the bandwidth. How to keep the bandwidth is large as possible. For example, right now we already developed 1 gigahertz or 2 gigahertz. So you can get more better resolution. Because resolution is 1 divided by the bandwidth. So in the bandwidth large, it means the resolution is smaller or better. It is okay. The bandwidth is not just the antenna bandwidth, but all of the system bandwidth is much large. It's very difficult and costly.
Okay.
It's in the point.
Okay. Thank you, Prof. Jos. I have question for Prof. Nafa Rizal regarding I'm interesting cold plasma dingin. How to maintain the cold plasma, because the cold plasma have properties can repeatable in low temperature.
When we talk about cold plasma, is considered as a room temperature plasma. So room temperature plasma is where the ratio of the ionization is less than 10%. So when we have a gas, so the gas is only 10% of the plasma is being ionized, of the gas being ionized. So that one we call as a cold plasma. And the temperature of that plasma is considered at the room temperature. So to maintain it, we just need to make sure that the gas pressure or the gas flow is at at is just a normal value, where the gas flow is maybe right around 80 or 50 SCCM. Normally we use it, and the pressure is less than 100 millitorr or 200 millitorr. That is the normal pressure that we use in the chamber. So by having that, and then the power supply is like only 100 watt or 200 watt, so we can create this kind of cold plasma, and it can sustain.
Sustain for repeatable.
Yes, it can sustain for. Normally in the semiconductor industry, they use the system, they call it as a cold plasma.
Okay, thank you very much. The time is out. Yes. Now the end of presentation, and please give us applause for two presenters. Thank you very much. We would like to say again for Professor Josapa Tetuko Sri Sumantio and Prof. Nafa Rizal for their informative and interesting information, and to audience and for this Icimece conference. We believe that this presentation will be beneficial not only for science and technology, but also for exchange new ideas between leading academics, scientists, researcher, and research scholar. Thank you very much, Prof. Josapat and Prof. Nafariza. And the times to the Master of Ceremony. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Engineer Ferry Adrianto, for being an amazing moderator. Then, before leaving the stage, we would like to give a memento that will be given by the moderator. Now that we have finished our first panel session, we will continue to our second panel session, which will be brought by Professor Kang Hyunjo and Professor Igede Pasek Sutawijaya. And the moderator for this session is Inyoman Wahyu Satiawan, STM SC PhD. To Inyoman Wahyu Satiawan, the stage is yours.
Good morning, everyone. My name is Nyoman Wahyu Satiawan. I'm going to be a moderator for this session. And we are happy to be here on Icimece International Conference in collaboration of State University of 11 Maret, UNS, and Electrical Engineering, University of Mataram. In this session, we will have two speakers. The first one is Professor Kang Hyunjo from Department of Electrical and Computer Engineering, University of Ulsan, South Korea. And the second speaker is Professor Igede Pasak Sutawijaya from Informatic Engineering, University of Mataram. For Professor Gede Pasak, please come to the stage, and Professor Kang Hyul Jo, according to the information from the committee, will follow the presentation from online, using Zoom. Is that right? Yeah. Okay. Is that any Prof. Kang Hyun Jun already on the Zoom at the moment?
Yes.
And before we start, I'm going to read a very short CV of the speaker. The first one, Professor Kang Hyun Jo, received his PhD degree in computer control machinery from Osaka University, Japan in 1997. And now he is a dean in the School of Engineering, University of Ulsan, South Korea. His current research interests include computer vision, robotic, autonomous vehicles, and ambient intelligence. And also he is member of the Institute of Control Robotic and System, member on the Society of Instrument and Control Engineering, and IEEE, Industrial Electronic Society, and Technical Committee of Human Factor Chairs. He is also board members from International Journal. And the second speaker, Professor Gede Pasak Sutawijaya, his educational background, undergraduate and master program from Gajah Mada University, and for a PhD, doctoral in Komumato University, 2010. And he now currently is a head of department in Informatic Engineering, University of Mataram. His current research is including pattern recognition, artificial intelligence, image processing, and computer vision. Professor Pasak will present the topic of presentation with the title COVID-19 infection detection based on lung X-ray and voice recording of post-cough and future application. Good morning, Professor Kang Hyun Jo. Are you with me?
Yeah, good morning. Yeah, sure.
Yeah.
Can
If
you
you're
hear
ready,
me?
can you start your presentation?
All right. Thank you very much for your welcoming us. Okay, you can see my presentation material too, right?
Yes, we can see.
Yes, okay, then, perfect. Yeah, my paper title today is Vision-Based AI Service, Artificial Intelligence Service. Mostly that is from my experience. So you can see the overall concept and what I have intended through my research work. So while I'm proceeding my talks, if you have any hindrance, please let me know. Then I will give it a little bit detail. Okay. Well, first of all, I'm very sorry not to be there in presence. Actually, I have intended to be there by flying from Korea to there directly. But unfortunately, it is not so easy during the semester because I have so much of obligations to work here too. So I couldn't make a success to be there. I'm very sorry about that point. This is my brief CV where I have studied and also where I am working, and currently what I have done and on process. So mainly I have been working in computer vision based artificial intelligence or some application target like robot system or autonomous vehicle systems. So at NEI, I would like to pick some items to be addressed today. Recently I have been a project manager of Korean AI dataset archiving projects under the name of Drone Image for AI Data 2020. So that was good experience for me to get a good data sets and also to use those data sets for artificial intelligence systems or services. So I like to debrief that kind of work today. Very happily, I have been a good success delivering good journal papers because of I had a good chances to work in that field. Especially I have worked in the IEEE Industrial Electronic Society since 2011. I have been worked as an EDCOM member there, but in 18 to 19 for 2 years I have served as a secretary there, so I have a very good relations with the international arena. So I think today this is also a very good moment for me and for us to have a more human networks to keep on or expand this kind of activities in the future. So recently I have worked in quite much of things, but let me introduce myself a bit briefly here. I'm from Korea, so Korean Peninsula is located here, nearby the Japan and between the Japan and China. Now you are all staying in near this Java Islands, Lombok, I heard. But I have never been to Lombok yet, so on the next time I will travel to there. So I think that is quite far from my place to yours, but it is a distance from our sentiment, emotional one. But if we are human connected in the future, then we are going to be here much more nearer, I think. So I really hope this will be near future. We're going to have that things. So this morning, I'd like to introduce my ideas with the contents of these 1 to 6 AI services from the image or data collection, and I explain some ideas which have been national information agency in Korea under the name of the Korean government. So NIA has been working on the data collections for AI. So as I mentioned very briefly, I have also have a PM project managers on drone imagery. So I would like to say what kind of derivative services as an AI service. And of course, recently I'm also working on the traffic on mobility, especially future mobility idea. So I'd like to debrief very briefly, and then I will say some advertisements like a contest and conferences. These are my contests this morning. Actually, in Korea, we had initiated data collection, data archive for AI. So that was initiated in 2017. So every year, Korean government initiated to generate almost 200 projects. So National Information Agency under the Ministry of Education and Science Technology, that AI data collection and archive projects has been itemized each categories almost $2 million per project. So I think this has covered so much of data archives in Korea now. So because that is a good pivotal moment to get a quite diverse coverage. For example, natural language data and vision data, healthcare data, navigation data, safety data, agro-livestock data, and eco-landscape data as well. So there are not so much of restriction though, but good quality of AI data is so important to pursue the AI world. So now in Korea, at least this NIA project has been very successful under the name of the AI Hub for Korean researchers or technicians nowadays. At the time, in 2020, I have worked for drone imagery archive collections. So I have initiated as PM in the affiliations of the main University of Ulsan, my university. That was almost 2 million, more than 2 million, but that was already done. So at that time, I have co-worked many companies and some agencies, like university too. So basic idea to collect various data sets, at the time, how we can do, that's important. So to make a good concise or abundance of the data sets, I have to design these are things like 4K video data is important because high quality data is important. So at the time I have categorized the 3 different categories, like the amusement park area and downtown area in the urban area, and also mountain area. I have intended these 3 categories as quite good things for getting a more vivid and high fidelity data. So if I say that as a nutshell, almost all was good, very excellent, but the mountain data is quite similar between any mountains. That is, I hadn't expected that before my planning, but after the work, I have realized, okay, mountainside or Korean Peninsula is quite abundance of mountains, so almost mountains are almost the same fashion in the aerial imagery, aerial drone imagery. So additionally, not only video data, I proposed the LiDAR data to get some more as an additional versions. So anyhow, we have segregated 3 categories like an amusement park and downtown and mountain area. So to get a good data sets, it is not easy to, because there is too much of the labor work. So I spin off the works for each company, drone image taking company. So I have collected 3, 4 companies to collect the drone imagery data. So to do that, and then anyhow, I have allotted 3 categories of that. So many areas in Korea, even though 3 categories of the world, amusement park, downtown, or forest or mountain. So we try to collect for the 4K drone high fidelity image and also some additional LiDAR data. So as you understand, amusement park, we may think many kinds of objects like many cars or trees or human pedestrians on the road. And also cars also have not only the cars, traffic signs or buses, motorcycles or trucks, traffic lights or banners, pedestrian, street lights. So these kind of items are very, very important. When you are thinking of other data sets like MS COCO data sets, there are also many different types of the objects will be appeared in the historical data set. But here, this drone image is a bit different because the viewpoint itself is a high altitude, and the downward camera will see the street or the town, right? So the objects itself, even though we say the same categories like a human, but humans in the frontal view is quite straightforward, but above the air, it will be seen in a different directions like a slant or short. So that kind of thing is a bit different phenomenon of the geometry. So same fashion, in a downtown, objects category is also quite similar in the cars or humans or motorcycles, but the banners or the buildings are quite different. Buildings are, nowadays urban buildings are getting bigger and bigger, so the bigger building has the roof. That roof is also very wide. So in some case, as you see in the example like here, that those rooftop is not such a big importance yet. But on the street, on the other hand, on the street way, the cars or the some areas like zebra crossings, that is important to pick where the target is taken, or what kind of events or what kind of actions will be happen. That is also very important to be used as a especially AI service. As I mentioned previously, in the forest or mountain area, that is a bit different because almost in Korea, the summer season or the autumn season, the project has been done during the summer and autumn season. So during the summer and fall season, the most of the color of the mountain is almost the same. Yeah, greenish or a bit reddish in the time by the time goes by to the fall or winter, right? So not only that, some trails like here, human or trekkers, mountain trekkers are walking along. That is a bit different. So while amusement park or downtown urban area, the forest mountain is a bit a different fashion, as you see. So that was a bit misusable in some cases, except trackers detections or some wildfire or fires case. Except that one, but you know, fire is not such an often occasion, so we couldn't catch fires during our processing. So anyway, these are have been done. As I mentioned, additional LiDAR data set is also important. At this time, I have proposed that this project, why not try to use the LiDAR? But you know, the LiDAR sensor itself is usually on the market. They are limited in the ranges. So usually 100 meters or 150 is almost maximum. So it is not easy to catch small, but only in the street way or the downtown or the mansion area, some cars or some houses could be detected. That was our topic, what we have done through this research project. So then how during this 5 or 6 months period, we have collected more than the schedules, more than the esteemed archiving. So we collect almost 41 hours data imagery, and also LiDAR data. There was also 60 hours. I'm sorry, 60 minutes, more than hour. So, as I mentioned, we have proposed 3 categories of the area, but the area category will be grouped in many different places. You know, I mentioned, for example, amusement park or attraction places. There are so many parks or so many amusement places. So we could set up many different places to get a more wider variety of the data set result. Same way in the downtown city places also, not only in my hometown in Ulsan, and also different places like Daegu or Busan or Jeju Islands and so on. Mountains, as I mentioned, many other different places we have taken, but as I mentioned, the mountain top view is almost the same. Not same, but almost same. So I thought this is not such a good result for collecting the archive data. So what we have done using those of the imagery, first to get a data set, then we want to use those data to do some services using the AI technology. So for example, we could generate many kinds of the learning models to collect specific data like cars or trees or buildings or people. That kind of detections or categorizations or segmentation is important. So for example, using with this kind of raw data, so we could collect many tree areas, and also we could collect many cars areas and building areas and so on. So these kind of segmentations is so important, and detections as a bounding box is also important. But in the case of the amusement park, there are quite bunches of the trees that is tree area, for example, or the stores or the buildings areas. This is quite big in the portions of the image. But on the same way, in the case of the urban area, most of the imagery will be taken as a building. But in some cases on the streetway, then the many object targets like cars are going to be detected. That kind of bounding box treatment is important, so we have done that. And also in the mountain side, as I mentioned, most of the hillside or the tree forest side, they are almost the same fashion. But on the contrary to that field, but some trail road that is a bit different. So we could get that kind of segmentation through this imagery. So we could collect this kind of segmentation for a trekking area or a trail area. So that kind of segmentation was important, especially when you are doing this kind of idea to expand to other different places like a riverside or harbor side, port side. At that time, we are going to get more different fashions like a watery area and a street or town area. So that kind of segmentation is important in the future. So later, after this work, we also applied this idea into a port area. So that was a successful for us. Segmentation, what I mentioned with LiDAR data collects distance data too. So we could get a bounding box, but that bounding box is going to be three-dimensional later. So some volume of the cars are going to be taken as one boxes. And so this was a good data set for implementing the AI service too. At time we have done work, so much of things to do, so we have trained new persons, young students or new persons to work together with us and so on. So we also developed their software too. So for example, so how to make the archive editing one. Oh, this is a bit slow, so yeah. And so we could do this kind of bounding box work by training, and later we could training model too. We could get this kind of idea continuously. So we could get data first, and then working with an AI team as a co-source, and then do process to make better training model. So we could do this iterative work continuously, so we could generate a model, training model. And then, as I mentioned, AI services is important. So at the time we do some missions like car detections, according to car detections, how we can generate a traffic analysis service, and also we could collect human pedestrian or human detections. So using that idea, missing person detection service and so on. And of course, we could get a congestion on the street by the traffic jam or not. We could get kind of AI service. So many kinds of the traffics. So we realized many additional or derived AI services later. Especially human re-ID, it was very, very successful to be used in the wider area to select or to detect the missing person. So in the wider area, because the drone could see the wider area, so in that area, we could detect a certain person's and imagery, wider imagery. So it is not easy to find a persons in the on the street or on the urban area. It was not easy, but except using that drone image. So drone imaging was going to be used for very good AI service for detection of missing persons and so on. So it's quite similar way we could also counting the people in a certain park area, how many people are gathering there or crowded or not. So according to that idea, what they are doing there, like a human behavior action recognition. That kind of service is also very, very important in the AI era to get more interactive information to be used in the future. So at that time, we have tried to devise many different kinds of deep learning methods to get an urban security drone services too. So I would like to speed it up because of not so much of time now. So during that idea, we have learned many good things because young people nowadays they are very, very eager to learn more AIs nowadays. So we would like to promote and foster them to make a hackathon software marathon game during the 0 night 2 days competition and so on. From this idea, I would like to speed it up. Sorry. So that kind of idea, we have good, interesting things, but I'd like to speed it up because through our experience, we found governmental aid to collect the AI data archives. It was very, very good things, good big trust to promote the AI business. And also, first, they provide a good New Deal policy, fiscal New Deal policy, and also good data collections, and also using that AI archive data, so that is pivot to apply new varieties of AI services. So that could be used a variety of industry, and many other approaches could be uprising or generated for future researchers and developers. So this is a temporary entering my conclusion, but I'd like to add in a bit additional information like autonomous driving contest history. So from that experience, we also have initiated a new contest. So for example, I was working as IEEE Industrial Electronics Society as a ADCOM member for long, So I having a very, very good friends to work together in the worldwide. So I have initiated the new international workshops on intelligent workshops in my town. This is also sponsored by my metropolitan government. So this year there was a third. This year there was a third. We also initiated a new contest, like an autonomous vehicle software contest. That was what we have done in the last August 8th, supported by Moray Company, Incorporated Company. They provided a simulator with using the software-based simulator. So we initiated cars on that simulator. That cars runs autonomously. That runs on the whole circuit. According to that road situations or road obstacles, according to that situation, they could adequately working well or not. We could check and count in their test value. So evaluate after that evaluating, we could get them have those awards from that contest. So that was this picture was a hackathon for autonomous driving in conjunction with IWIS International Workshop on Intelligent System. So next year I'm also going to organize that in my town again. But this year we also have worked on this onto Panama University of Technology in Panama. We have this kind of contest in the UTP campus again in the last month. To do that, we also have to educate the applicants, mostly students, applicants to through online meeting. We teleconference meeting have a conference to real-time feedback. So we train them, and then we have started that work in the UTP in the panel. So quite similar way, I have through that drone imagery, I have started with traffic or autonomous navigation work. So not only on that the cars, I'm also thinking about that, including the cars, maritime ship or air mobility context. So this will be also maritime autonomous navigation or driving contest at IEEE ISIE International Symposium on Industrial Electronics 2024. That is going to be held in my town. I'm the general chair of this conference under the IEEE IES Society, as I mentioned before. That is also located in this webpage, IEEE ISIE 2024.org. So you could see that. So you can join on the next year's program. So I just added some advertisement, but these are going to be working together internationally and also working together in the near future technology development, especially for the traffics and the navigations, or especially ITS or autonomous navigation systems. So thank you very much for your attention, and I'm really looking forward to seeing you in my town, ISIE 2024 or IWIS 2024 too. Thank you.
Thank you for Prof. Kang Hujo for the interesting presentation, vision base of AI service. And now we are continue to the second presentation from Prof. Pasek, please. And then at the end we have a answer and question session.
Okay.
That's okay. Good morning, everybody. Thank you for the committee of Icimece 2023 for giving me opportunity to speak in front of you. And thank you also for the moderator today, Pak Wahyu. How many minutes I have? You give me a time? 30 minutes? Okay, thank you. Okay, okay. Today I would like to share to you about my recent research in University of Mataram, especially in my laboratory, we call it Export System Laboratory, entitled of COVID-19 infection detection based on lung X-ray image and voice recording of post-CAP and the future application. My name is Igede Pasak Sutawijaya. I am from Informatic Engineering Department, University of Mataram. Next. Next, please. Next. Okay. Even though already guns, everything is ready guns. Almost 3 years, everything of our activity was stopped, right? We just work at home and doing lecturing in by Zoom, and everything was in home. So, but it still have problems with the virus because COVID-19 is caused by the respiratory syndrome coronavirus, or we call it SARS-CoV-2. And in 2020, the WHO declared that the disease was as a global pandemic status. But today it's already done, but still relevant we talks about. Next. In that time, there are many infected people. They didn't exhibit the physical symptom of the disease. So it's make scare of our community, not only in Indonesia, but all over the world, that the infected patient who didn't exhibit the physical symptom will cause spread the infection to others. So next, please. So, and the report from the Center for Disease Control and Prevention said that almost 50% of the transmission rates caused by the asymptomatic people who didn't show the physical symptoms. Next. Please, according to World Health Organization, that's a novel coronavirus is a new strain that has not been previously identified in human. So in another statement also said that the coronavirus is a drugs variant of virus. So there is possibility in the future will come against to our society. So that's why I said that it's still relevant that we are talking about. Next. Please, this is already okay. This due to the large family of virus, it's common knowns that right now we have MERS-CoV and the SARS-CoV. This is from the Middle East at the first one, and the second one is appear in all over the world. Next, please. So that's why the coronavirus they have properties of we call it zoonotics, which means that the transmit between animal to they are transmitted between animal and people. So that's why we have to be aware with this kind of virus, because it's possible to become come against in the future for our society. Next. So this, according to as well known to all of us, because the COVID-19 was caused by coronavirus, which the symptom looks like this. So fever, coughings, and body aches, runny nose, shortened breath, sore throat, loss of sense of smell, we call as anosmia, and lost sense of taste we call as ageusia. So these two kinds of symptoms is quite dangerous. It's quite scary for the humans, because sometimes when we got very strong fever and strong runny nose, so sometimes anosmia come to our bodies, and also the ageusia is come. So that's why we still to take care with the kind of virus because they have many large strain of the virus. Next, please. So start from in that time we have to everybody, even we didn't show any symptoms to our body, we have to make tests. If we move or we make a travel to another side of the country, not for the roads, but even inside of the country, we have to take the test. But the problem is, in that time, the test take time, and so next the government proposed the surveillance test just based on the antibody test. The health worker will just take only 1 or 2 hours, maybe less, or become 30 minutes for the surveillance. But it still need another methods for detecting the COVID-19 virus. Not only that, but also the other virus who possibility with possibility to infect the humans or society. Next, please. Next. So in this, my last research proposed on another methods based on the X-ray check, chest of X-ray or lung X-ray, because in Indonesia, all of the hospital has the facilities for getting the X-rays, and then there is less of radiation to expose compared to the CT scan, and also the price is not quite expensive. So that's why our laboratory tried to develop a method for detecting the COVID-19 using the X-ray, and also the based on the cuffings, recording cuffings. Next. But the limitation of X-ray, as we know, it's well known that it cannot be repeated in the future, and the radio of the result can be done by the expert. It means that only expert can be interpreted the image whether this is one is pneumonia or COVID-19. Next. So between the two, if you see, it's quite hard for us, even for the radiologists, to distinguish which one is COVID and which one is pneumonia. But this one is the image exactly very clear where is the COVID and where is the pneumonia. Because in the left one is COVID and the right one is pneumonia. Because the left COVID, there is many blurry in terms of our lung. Next. So based on this information, so the resemblance of the COVID-19 to other pneumonia virus infection is quite difficult to distinguish by the radiologist. So that's why we need another technology. Another possibility to detect the disease, infection disease, based on the we call as asymptomatic and healthy people according to their coughing. Now, how they cough. For example, in this case, we show you two difference of coughing recordings voice. In the left one is the COVID-19 and the right one is normal. If we see from the recordings, it's quite easy to understand, but the normal one is, it looks like, how to say, repeatedly, or we call as periodically. But here is non-periodic. Something is like, in the left one is hard to cough, but the right one is like, how to say, it's little bit easy to cough. Next. Therefore, next, we need a computer, we call as computer plus AI to make a detection any disease in order to have the health worker even in our province in West Nusa Tenggara. Previously, our governor says that in Lombok we have 2 big islands and many small islands. They have less infrastructures. There is no internet. There is no electricity, and everything's very, very limited. So that's why we need to develop a simple models that we can detect not only the we call as COVID, but also for the others disease. Next. But in this research, still working for the only COVID. Next. Oh, next, please. From this one, I think how we work in our laboratory, we start from how to build the model detecting COVID, and next is how to build the model predicting COVID based on postcard signal, and then the next is how to develop the application. In this case is we developed a mobile application that is easy to use by the health workers. Next. This one, for the first one, we start from the simple ones to little bit the high-end ones. The first one, we just use a classical pattern recognitions based on the features and classification algorithm. But the second one, we use the CNN and the deep learning. In this case, why we use these 2 of algorithm? Because we want to implement the model in the low resource devices. Because as we mentioned previously, because in our area in West Nusa Tenggara, we still have underdeveloped rural area with limited resources, very, very limited resources. Sometimes there is no doctors, only 1 nurse, and then sometimes even 1 nurse there is no in that place. So that's why we need such kind of technology that can be developed for the rural, very underdeveloped rural area. Next. But in this case, we still have the limitation. As I don't know, in UNS, in Solo maybe, it's a very big city in Indonesia, because I have visited Solo for several times during my study in Gajah Mada University. I was 10 years in Java, especially in Yogyakarta. So that's why I know very well about Solo. So there is very big city. I don't know whether that's also is very difficult to find the data, especially for for medical data. In Mataram University, it's quite hard to find. Even University of Mataram has a hospital, University Mataram Hospital, but it's still difficult to find the data. It's not easy. So that's why in this research we still use another university data, and then. But right now we already running collaboration between Faculty of Medicine to doing this research together. But one of my tool that's already implemented in Puskesmas, we call it Puskesmas or General Public Health, once for the ENT devices that we already share in the Puskesmas. Next. I think you can pass this one. I think this is quite simple. Next. Okay, now, next please. Okay, for the simple ones, we just developed a classical model, just the model based on the feature extraction. We use the discrete wavelet transform, if you well known this one, and moment invariance in order to detect the features of the COVIDs and non-COVID, and COVID and pneumonia. So we just use that information to make the classifications. Next. So for my research, we use almost 15,000 images, which separates into COVIDs, around 3,000, pneumonia 1,300, and the normal is 10,000. It's quite big data. Next, but it's unbalanced data. Next. This is the still simple algorithm. We use just the data and then we convert to grayscale. But sometimes the data recordings in the for X-ray they put in the RGB data, and then we need to convert the grayscale in order to downsize the computational time and the resizing and the normalizations. Next, please. And then we need to extract. We use this classical model. We need to extract the information. We use the discrete wavelet transform in order to divide the original image into the four we call as bands. Each band we take the information based on the statistical value and also the moment invariance. Next. We use the 7 moment invariance for detecting, for getting the features of the X-ray images, because from the invariance moments we can understand clearly that if the image has small difference between the others, they will have the same value of invariant moments. Next. Please, we use of course, this is standard model testing. In the AI, we use the confusion matrix, which will be counts from the true positive, true negative, false positive, and false negative. Next. From that one, we will use the parameter accuracy and loss and precisions and also recall for knowing whether our developed models works well or not. Next. This is the result for simple models because it's very simple, because we just use number of hidden is 2 layers and number of neuron is around 128 times 64, and another size input size is 128 and 128. And then we got only 87% of accuracy, precision around 88, and so on. And then based on this one, but we can we can understand here even the accuracy is much less, but we still understand that the COVID can detect is very large, around 258. The COVID's actual COVID class we can detect almost very high. Next, please. And then from the data sharing test, we use a K-fold. We got almost similar performance than the previous ones. Next. Okay, and then we compare our proposed method to the what we call is the assisting method. This is we compare into 5 algorithms with the parameter is very big. Suppose that, for example, we use convolution block attention module ResNet. They has for almost 48 million. So if this model implemented into small device, it will not work. Okay, and so that's we need a small model, but it's still acceptable for the low resource devices. So our model just need 11,000 parameters in order to implement it in low resource devices. Next. Next is we use decision and algorithm in call as deep learning, and then in this case it's little bit complex models, but this will be implemented in the cloud. So suppose that if the health center already have the internet connection, so we develop this model. This model will work for the Puskesmas or the health center which has the internet connection. So from this one, next please. the developed model has almost 8 million parameters. It's still much less than the available methods. So by the 8 million model parameters, which if we implement it in the cloud computing, it's still reliable, and then only the back ends or the UIX we put in the mobile devices, and then if we have the data, and then we transmit to the cloud, and the cloud will detect whether it's copied or not, and then the result is giving back to the mobile device. That is only works for the health center who has enough internet connection. But if you don't have this one, so we will work with the small ones. Next. So if we compare the algorithms with another, that existing model, we still get a good accuracy compared to the previous one by about 90% of the accuracy. But the detection time is much less than the existing method. Next. And next, for the another force curve signal, we use a simple model also. We call as, we use the MFCC here to detect the feature extraction, and then we use ANN, artificial neural networks, and support vector machine as the classification. Next, please. The algorithm is quite simple. If you have the force curving signal, and then you convert to spectrogram, and then extract the spectrogram data, and then we convert the spectrogram into FCC of the data, and then we create the classification model. Next, please. This is the model, ANN model that we developed. This is the best model that we found based on our features. Next, please. And we got almost over the 90% of the accuracy, but we got very bad of the recall. So because the data is quite little, it's quite small, just only not more than 100 data. So as I mentioned previously, it's quite hard to find the data in Indonesia. So, but we still working with the member of faculty of medicine in our university to create more data for doing more further research, not only for COVID, but also for other diseases. Next. And then we try to use the smoothie in order to offer sampling the original data. And then we got almost 99, almost 90, more than 98% of the accuracy, 99 of precision, and recall 92, and F1 score is 95. This is quite good result. But the data is we use as smoothie to offer samplings the data. It looks like the augmentation data, but this is not real data. Next, please. And then the next, we use the SPM models, just the same feature extraction, but we use the SPM for the classification. Next, please. Next, please. This is the performance, and then we got more than, but some cases we got the accuracy more than 92%. Next, please. This is original data. Next, please. And then we add oversampling using smoothie, and then we got almost similar to the previous one. It's very good performance. Next, please. After we got the models, the best model that we got by our research, and then we developed the application. The applications, in this case, for the high-end application, we use for the mobile application. We assume that the center of health or health center they have internet connection. So that's why we use the API for connecting to the internet. Next, please. This is the models of the application. Suppose we have the ends of end user. We use the mobile applications, and then all of the model for the classification we put in the server. But this one is only used for it's developed for the health center who has the internet connection. Next, please. And then we define the application design, start from sequence of login processing, because if the user use this application need to logins in order to limitation the unregistered user. And next, the sequence of the diagnose, we need to input the image and then add the image, cropping the image, because not all of the information in this image we need it, and then we need to crop, and then we perform the diagnose. The diagnose will be done in the server, and then the result will return back to the clients, just so whether this one is positive or negative. Next, please. In the application, we also use for gathering or data acquisition or data annotation, because sometimes when the doctor use this application, maybe the our application provides not correct or false positive or false negative result. In that case, the doctor will give the goods or the correct one of the decision. So from this data, we can put again into the server as the new training data in order to improve the models. Next. And then the applications, the application interface is make as simple as user needs. So just sign in and input the image and diagnose and the prediction result. And after that, the annotator or the user can make a suggestion. Next, please. And then, in order to know whether our application is good or not, we try to evaluate using some devices, mobile devices. We use only 2 years. We want to know whether this one is can work well for the device or will be interrupt the device. Next. In terms of the application evaluation in terms of user interface, we use the SUS for applying whether this one is good or not. And then we use here 45 respondent to make adjustment or to make assessment of our application. The respondents come from the student of informatics engineering, student from the medicine, and the health worker in the sum of our partner in around Mataram University. And then based on that respondent result, we got more than 67 standard of US of only the standard is around 67, but we got 71. It's meant that acceptable. So it's meant this application is considered as good, but still need to improve because maybe some of the features does not work well, and some of the connection still lost. Yeah, as we know that the internet connection in Mataram also not quite good. It's quite fast, like in Malaysia maybe, or in Japan. It's quite different. Next. Okay, thank you. So our conclusion is we can detect this COVID-19 using our proposed methods, and for CNN is the best one, but the artificial neural network also good for detecting the COVID, especially for post-cuffing, and the SPM also provide the best model. Next, please. about future workers and the future application. But in terms of this research, we still need improvement. Firstly, by augmenting the images, ending the number of data sets to improve the performance, and optimizing the mobile for the Android platform and for the small computer applications. Next, please. But in terms of our research, we still need to improve for the future application. Because as I mentioned previously, because we have many underdeveloped rural area, so we need to develop to convert the Puskesmas, public health center, into we call as e-Puskesmas. And this is still ongoing research in terms how to convert the Puskesmas, the manual Puskesmas into electronic Puskesmas by ICT and NI in terms of software, with two main features. Firstly, for offline features, this will work only offline without internet connection. This is really needed by the health workers in underdeveloped rural area. And the second was an online feature with the high sophisticated detection and recommendations such as pneumonia, tuberculosis, and tuberculosis detection application. So right now we got the information from our partner in medicine faculty. They said that because many of society afraid to come to the Puskesmas because of COVID adjustment. Okay, if you come, then they will say you are COVID. So many people is afraid to come to our health center. So what is the problem come through? The problem is right now there are many pneumonia and tuberculosis increasing in our area. So that's why our partner said it's needed to be developed this application into pneumonia and tuberculosis application for the underdeveloped rural area health center. Next, please. What is the model that we designed? The model is all of the models that can connect to the internet we put in the cloud computing, and then the small model that we put in offline application, including the data acquisition and data annotators, and of all of the application that can connect to the internet, we will put in the mobile devices because it's quite easy to access, and many people has right now in Indonesia especially, they have mobile devices. Next, please. So in the Puskesmas, we will have the features something like this: COVID screening, pneumonia detection and classification, tuberculosis detection and classification based on the X-ray, and then the smart ENT disease for classification, and etc. So this is still developing. We are still doing the research together with our partner from the medicine faculty. Hopefully, in near future, we could implement it. We could support the government to make our society become healthy and healthy. That's all of my presentation today. Thank you very much for your kind attention. Hopefully.
Thank you, Prof. Gede Pasek, for the interesting presentation. Now we are entering to discussion session. I hope Prof. Kang still online, yeah? And Prof. Kang already start by artificial intelligence data of flight image for autonomous drone, and process including collection data, the object detection, and then data process and validation. And the last one is development of artificial intelligence service, including traffic analysis service and missing person detection and pedestrian detection. And Prof. Pasek already present regarding with COVID-19 detection. Start from the background that there is no physical symptom on the COVID-19, and also the possibility will come again in the future. So the method here mentioned is this X-ray method and recording of catching, yeah. And he also explained about the artificial CNN, and the data and the process of the to get the conclusion of the 71.3 accuracy of the process. I hope one or two questions. We have a 15 or 20 minutes for discussion. One or two questions from the audience. Yeah, Pak Harry, please mention your name and then or whom the speaker address the question. Yeah.
Okay, thank you very much. My name is Heri Wijayanto from University of Mataram, and I have a question. Firstly, I say thank you for two presenters today that talking about interesting research, talking about AI technologies. So, as presented by two presenters today, that AI have many benefits for people. And I also heard that today also, AI technology is used for the negative thing for the human life. For example, to create the fake news, and also maybe to help the hacker or cracker to attack the system information. So maybe my question is not for Professor Pasek Sutawijaya or Professor Yung Cho itself, but maybe for the both of the presenters today. And I want to know the opinions from the two presenters today. That's all my question. Thank you very much.
Thank you, Pak Heri. The question is about another thing of application of AI regarding to hog production. This question is addressed to both presenter, yeah, Prof. Pasek and Prof. Kang. Yeah, please.
First, hello, Prof. Okay, maybe
If I say about the security problem, it is quite hard, but it feels in the AI service.
Maybe I'm sorry, Professor. Maybe it is not about security problem, but the negative impacts of the AI technology, like that. Thank you.
Okay. So not only the security problem, the AI service is also very widely used in the future, yeah, through the network. So in that case, we may say about that the security is also imposed with that services. So I think that is a very, very hot topic for the security guys. And also, we as a AI lateral side, that is also very important. So I think in each AI service engineers or technicians, they are also taking into considerations to how to make a breach or threat proof way is important to when they are proposing their idea. So not only that AI service itself, every corners of each service when they provide it, they must show their schema to set up their security for that AI work. So, for example, some data will be breaches from others illegally, then that has been secured, and also not only that, the data set itself, that the service latency should be shrink down to get back to the users. So I think because of the AI service itself is not such a big mature yet, so it's going to be a growth period now. So we are going to consider more deeply about that services. That is just the outline of what I'm thinking.
Okay, thank you, Prof. Kang, for the answer. Please, Prof. Pasak, to
Okay.
answer the same question.
Thank you, Pak Heri, for your question. I think this question is come for many peoples because when I joined the Aichaita last month in Senggigi, there is such kind of question also. As we know that the advantages and disadvantages of something is happen in our life. But from that one, we have to be use our human being capability to to adapt or to take the benefit of any kind of AI right now that is available in front of us. For example, maybe last 2 months ago, I make some question for my students. And then the question I put in chatbot, and then the chatbot get very perfect answer for that one. So I think if I give to the student for homework, then the student will put that one into the chatbot, and then they still just write down the answer, and then we'll got perfect answer. So I think, according to my opinion, is as a human being, we have to adapt that everything come to in front of us. For example, if AI come to us, and then we have to take the AI as the tool only, not as as the main point or main knowledge of ours. It means that our brain is acting to AI. I don't think so, because we still need the AI for the positive one, but the negative one we need to not remove actually, but we need to adaptable. For example, if I, as a lecturer, to make a question that can easily to take the answer from the chatbot, in that case, I don't give the student that kind of question, but we change the question as as pronunciation, as much as not written answer and question, but as presentation. So something like this one. In terms of the economics, for example, if all of our job exchanged by AI, what will the people do? So that is also the question, I think. So I think in the future, many of AI experts, even for the vendors of AI, said that we still limit the application that's exchanged for all of job. They still makes any job that needs many workers, they still exchange, but not all. So there is still possibility come for us for working in other side, but working as the AI developer also is possible. But right now, if we learn AI from the cloud computing, it's possible for the people who don't know any line of code to develop AI models. So it's possible, just by drag and drop. Drag this one, I want to do this one, and this one is a drag. For example, if you use Azure Designer, it's quite easy to make a simple model, even we don't know any line of code. It's possible. So that is the job for AI models for supporting our life is still available. Also in the regulation, I think the government need a regulation. Suppose right now we use autonomous car. If there is accident in that case, who will take the responsibility? Is the developer or the owners? Because the owner don't drive the car. They just sit down in the car and then the accident comes. So there is no rule yet. So still we need further rules or further regulation for the AI in the future. I think that is my opinion, Pak Eri. Hopefully answer your question. Thank you.
Thank you, Prof. Asek. Yeah, it has technology just like a two-faced sword. So which one should we take? And Professor suggests we have to adapt with the situation, and then we also put more ethic and morality on education, and also to make more regulation regarding with that, because this is quite new and need more regulation from the regulator. I have a message from the committee that we have already in the end of the session. So thank you very much for Prof. Kang Kyu-cho from Ulsan University, South Korea. Thank you for your inspiring presentation. And also thank you very much for Prof. Gede Pasak Sutawijaya from Mataram University for an interesting presentation. Thank you for all audience for the kind attention. And we go to the next session, or the third session, and I will give the time to the MC. Thank you very much.
Thank you, Inyoman Wahyu Satyawan, for being an amazing moderator. Before leaving the stage, the moderator will give a memento to the speaker. And now we've come to our final panel session. For this last session will be brought by Professor Takahito Miyazaki and Professor Haznan Abimanyu. The moderator for this panel session is Dr. Engineering Insinyur Pringgo Widyo Laksono. To Dr. Pringgo Widyo Laksono, the stage is yours.
Tes. Bismillahirrahmanirrahim. Good afternoon. The third or final session will be about to begin. All ladies and gentlemen, Honorable Rector, Dean, and Dean of Faculty Engineering, Universitas 11 Maret, and Universitas Mataram, our distinguished speakers, distinguished participants, ladies and gentlemen. First, I would like to invite Dr. Hasnan maybe to come and join in front. Thank you. First of all, I would like to welcome you to this final session of the 8th International Conference on Industrial, Mechanical, Electrical, Chemical Engineering 2023. I am Pringgo Widyo Laksono. It is my great pleasure to be moderator in this conference that featuring the theme Empowering Innovation Through Green Technology for Sustainable Future. I would like to say hello also for all participants who join in the Zoom. Maybe we can see in the Zoom. Especially our speakers today from Japan, Professor Miyazaki. Are you with us? Miyazaki Sensei.
Hi, yes, I'm here.
Ah, konnichiwa, Sensei.
See you.
Before we start this session, I would like to introduce our speaker first. First speaker, Professor Takahiko Miyazaki. He got Master Science in Renewable Energy and Architecture from University of Nottingham in 2003. And in 2005, he holds Doctor of Philosophy in Engineering from Tokyo University of Agriculture and Technology. Now he is a professor in Department of Advanced Environmental Science and Engineering at Kyushu University. His research interests are thermal engineering, waste heat utilization, absorption heat pump, and etc. Maybe this is not your first as a speaker in this event. Previously, Professor Miyazaki also joined in the previous conference. And then the second speakers, this is Dr. Hasnan Abimanyu. Dr. Hasnan Abimanyu graduated from Diploma Engineering in Process Technology from TU Braunschweig, Germany. And he got PhD from Catalyst and Chemical Engineering from Korea University of Science and Technology in 2008. Previously, he joined Indonesian Institute of Science as a junior researcher, and now he appointed as head of research organization for energy and manufacture, National Research and Innovation Agency, or we can call BRIN, Badan Riset dan Inovasi Nasional. As a researcher, he conducted many research work, got several research grants, published papers in national and international journal or proceeding in field of catalyst and renewable energy. Ladies and gentlemen, without further ado, now allow me to invite Professor Takahiko Miyazaki for presenting the material, maybe 20-minute, Professor, and then later we'll continue Dr. Asnan. After that, we can do Q&A, question and answer. Now time is yours.
Okay, thank you very much for a nice introduction, and thank you for inviting me this conference again. So I'm sorry, this time I cannot visit Indonesia. Please allow me to do my presentation by online. So I'm sharing my screen. Is it working? Okay, the screen is okay, right? Okay, today I would like to talk about the thermally driven air conditioning technologies for carbon neutrality. So let me introduce myself in the beginning. So I don't need to explain detail because the moderator gave me a very good introduction. So my laboratory is Thermal Energy Conversion Systems Laboratory. So main research area the air conditioning and also heat pump technologies. And also I'm very interested in the absorption phenomena and also to use the absorption phenomena for the heat pump. So today's topic is mainly about the absorption heat pump. This is a member of my laboratory, and we have Associate Professor, Professor Chotu, and Assistant Professor, Professor Chayanisa. She's from Indonesia. And we have many students, more than the half of the students are international students. So my laboratory is a very international environment. In the beginning, I would like to explain the energy consumption for air conditioning. So this is final energy consumption data in Japan and also in worldwide. Generally, the energy consumption will be shown by sectors like industry, commercial, and domestic transport. So I would like to focus on this commercial and domestic sector because these are related to the buildings. So we can say the buildings consume about 1/3 of the energy consumption in Japan, and also in the world, the ratio is very similar. Although the air conditioning is used in industry and transport, so I would like to focus on my talk about the air conditioning in buildings because which has the large potential for the reduction of the electricity consumption by using absorption heat pump technology. So this is energy end use data in Japan. This is domestic and commercial. So this graph shows how the energy is consumed. So these are the purpose of the energy consumption: the cooling, heating, and hot water, cooking, power, and light. So in case of Japan, cooling doesn't consume much energy. It will be very different from Indonesia, but the heating use a very large portion. It is about 1/4. And also in Japan, we use hot water. So this cooling, heating, and hot water is actually what we need is thermal energy, especially the near environmental temperature. So cooling and heating is air conditioning. In that case, we keep the room temperature around 20 to 25 degrees C. Okay, so it is not much different from the outdoor air temperature. Also, for hot water use, we just need 40 degrees C. Okay? So also the temperature is like 20 degrees C or 30 degrees C higher than the environmental temperature. So this energy consumption is different from power, light, or cooking because for power and light, we need the electricity itself. Also for cooking, generally we use very high temperature by the incineration combustion of the gas or some other fuels. In commercial building in Japan, this ratio will be very various depending on the type of the building, but typically we can say that air conditioning, cooling, and heating will use about 1/3 of the energy, and also the hot water will consume a certain amount of the energy. So the space heating, cooling is about 1/4 or 1/3 of the energy demand, and also the heating, including the hot water, becomes about half of the energy in buildings. Considering the building consume 1/3 of the energy, so these heating, cooling demand will consume about 1/6 of the energy consumption in Japan, or it will be also in the world. So this is a concept to use energy more efficiently. So it is called the energy cascading. These are the demand for the energy. Like we want to drive the machine, or we need high temperature steam or just a thermal energy for the industrial process, or this is domestic hot water and air conditioning. For all these purposes, current technology, conventional system consume fossil fuels for each objective. For example, when we need power or electricity, we use fossil fuels and produce power electricity, and it will be given to each purpose. When we need thermal energy, it is also the same. We use fossil fuels, and then the thermal energy is provided to the industrial process or domestic hot water or air conditioning. For the conventional use, we have to consume fossil fuels for each objective. The cascading energy use suggests to use fossil fuels only on the top level of the energy demand. At high temperature, we can produce power or electricity very efficiently. But from the thermodynamics law, the second law of the thermodynamics, all the heat cannot be converted to the power or electricity. Always we have the waste heat at lower temperature level. But still, if the temperature level is much higher than the ambient temperature, we can generate power or electricity again, or we can produce steam. So if we have this 200 degrees C level of the waste heat, we can produce steam. And that steam can be used for the industrial process. Also, for the domestic hot water or some industrial process, doesn't require very high temperature. If the demand is this level, 80 degrees C, we can use hot water after we use the steam, and the condensate, the steam can still hot, and then we can use it for this purpose. Okay. Also, for air conditioning, especially if we need heating, this level of the hot water is sufficient. It is a little different in case of the cooling. So generally, we use air conditioner, which is driven by the electricity for cooling. But the temperature level of the air conditioning is not so different. It's not much different from the ambient temperature. For example, if we just need 10 degrees C chilled water, we can do the cooling. So today's my talk is mainly about this path from hot water to chilled water. If we can produce chilled water from this hot water level, we can also use the cooling within this energy cascading concept. Okay. But currently, there are not much technology to produce cooling effect from low-grade thermal energy. Okay. So then I'd like to explain the thermally driven air conditioning technologies. The key material is adsorbent. So adsorbent are used for separation, amplification, or dehumidification, which is a porous material. This material has a very small nano-level pores within this material. That is why it has a large surface area. Then it can absorb the large amount of the gas. Here I would like to explain the adsorption and desorption process. So please think that there are containers, and one will hold the adsorbent. For example, we can think this is silica gel. And in another container, we can put the water. When we just evacuate all the gas, and if we just have the water and water vapor inside, so this water vapor can be absorbed by the silica gel. Here, the water can evaporate, and the evaporation will take the heat from surroundings. So there is a heat absorption here. And then the absorbed vapor can be, evaporated vapor can be absorbed by the silica gel. The adsorption process, the heat release process. So here, the adsorbent will release the heat to the surroundings. So in this adsorption process, so the water vapor itself can transfer. This is the transfer of the material, but at the same time, the heat, thermal energy can be also transferred, because here there is a absorption of the heat, and the heat is given in another place. Here, this is a release of the heat. So in this way, adsorption process can transfer the heat and also the water vapor. Desorption process is the opposite. When we heat up the adsorbent, it will take the heat from surroundings, and the water vapor will be released. It will be dissolved from the solvent. And if we cool down the other water container, the water can be condensed. In this case, the water vapor flows from silica gel to the other side, and at the same time, heat is transferred from silica gel side to the condenser side. So in this way, if we use the vapor transfer and thermal energy transfer, we can make this as a heat pump. Especially what is interesting in this phenomena is we can use higher temperature for adsorption than evaporation. So if we don't have the silica gel in the other side, and if we get the evaporation of the water here, and when the other side is cool, lower than this evaporation temperature, the water can condense. But in case of the adsorption, even it can absorb the evaporated vapor, if the temperature is higher than this evaporation. So in this way, we can transfer the heat from the lower temperature to higher temperatures. This is very important to make this system as a heat pump. The performance or characteristics of the adsorbent is typically given as adsorption isotherm. So I just explained shortly about the adsorption isotherm and how the adsorption and desorption will form a cycle. In adsorption process, what we want is low temperature evaporation. So assuming if this is water vapor pressure, the water will evaporate at 7 degrees C. The pressure is about 1 kilopascal. That the vapor can be adsorbed by the silica gel. At 30 degrees C, the silica gel can adsorb up to this amount. This is the adsorption equilibrium. Here, this is about the 0.14 kilogram per kilogram of silica gel, for example. And then this silica gel should be heated. So if we heat up to 80 degrees C, then silica gel cannot hold this amount. The adsorption equilibrium at 80 degrees C is smaller than this value. That is why the difference should be released. This is a desorption process. When we continue this desorption process to equilibrium, then the adsorbent holds about 0.08 kilogram per kilogram, for example. Okay? But this desorption process can occur at higher pressure. Here, if the dissolved vapor have the 4 kilopascal, that is the saturation temperature at 30 degrees C of the water. So by this process, we can make the water at 7 degrees C, and then that water vapor can be condensed at 30 degrees C. So by this way, we can use the water vapor for the refrigerant of the heat pump. And then that pressure rise, pressure increase is produced by this adsorption and desorption phenomena. Here, this is the image of the adsorption heat pump for air conditioning. As I explained, the water vapor can evaporate at 7 degrees C. This is in the unit of the air conditioner. The water vapor at 7 degrees C is about 1 kilopascal, and it is adsorbed by the silica gel. Here, we keep the adsorbent at 30 degrees C, and there is a heat rejection. After a certain time, we heat up this silica gel at 80 degrees C. then water vapor will be released at higher pressure, like 4 kilopascal. That water vapor can be condensed at 30 degrees C in outdoor unit. So in this way, the water vapor and the silica gel can make this air conditioning work for cooling. Actually, this technology is commercialized already, like adsorption chillers. Also, the similar adsorption phenomena is used in this control, where it will absorb the water vapor from the air. So that is why this water will be used for the dehumidification. So generally, this kind of the adsorption refrigerator adsorption chillers can produce 10 degrees C chilled water from the 80 degrees C hot water. The 80 degrees C hot water is available, for example, from the drain of the energy recovery system or jacket cooling water of the engines. And also it is easy to produce the hot water by solar thermal collector. So by using this kind of system, we can make cooling from this low temperature level thermal energy. Okay. So this is the working principle of the two-bed adsorption chiller, because adsorption and desorption process has to be occurred in one system. So we generally use 2 adsorption beds, and one will continue the evaporation and adsorption, and another one will do the desorption and the condensation. These are the examples of the adsorption heat exchangers. There are several types of the heat exchangers, and it has the adsorbent inside this fins. Yeah, then this adsorption chiller technology is already commercialized, but it is not for the houses or vehicles. To make this system to more compact, and it should be low cost, and also the air cooling system, we need a large breakthrough to achieve this technology into this field. So in the research, in my laboratory, mainly we try to extend effective adsorption by producing new material or evaluating the existing material, and also we try to enhance the heat and mass transfer. So this is one of the examples of the research to enhance the adsorption, effective adsorption. So this is a collaboration with Professor Miyake in Kyushu University, that he can produce activated carbons. Then we try to produce activated carbon so that it can have a large adsorption and desorption difference for the heat pump application pressure range. Also, after we produce activated carbon, we tested it in the real system. Here we compare our new material, SAC, with existing commercialized activated carbon, ACP. This test shows that by using the new activated carbon, which has more larger effective adsorption, we got more heat thermal output. This is the adsorption heat, and this is cooling effect. So it can continue the longer heat exchange. Okay. So also as a system, there are many systems proposed. So these are just examples, but from we analyze the theoretical performance of this cycle, and we see by using these systems, we can improve the COP or the cooling effect. Also, to enhance the COP, the new type of the adsorption system, which is called double effect adsorption cycle, is suggested. And then,
excuse me, sir, Sensei, maybe 2 minutes, maybe, Sensei. The time is up. Okay.
Yeah. New system, new material also shows a very good performance. Yeah, this is all for my presentation. Thank you very much.
Thank you very much, Sensei, for your nice and very comprehensive presentation about your research. And then now I would like to invite Dr. Asnan for delivering materials. Now time is your doctor.
Thank you very much. Honorable rectors, deans, or representatives from University of Mataram and University of 11 Maret, distinguished keynote speakers, dear participants, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. I try to use 20 minutes, yeah, because I have slides more than 40. Then I will skip and rather fast. Can I use this one? No? Oh, thank you. Okay, next please. Okay, please allow me to introduce shortly the organizations of BRINS. So BRINS is directly under the presidents, not under the cabinets. So there are two wings of BRIN. First is the wings of structural wings. There are 7 deputies, and these deputies is to provide the all needs of research and innovation. And the right side is the right wings, research or functional wings, research organization. There are 12 research organizations, and from these 12 research organizations, there are 85 research centers. So one of these research organizations is my research organization, namely Energy and Manufacture. Next, please. Yeah, this is the research organization for energy and manufacture. There are 7 research centers. First is the Transportation Technology Research Center. Second one is the Research Center for Sustainable Production System and Life Cycle Assessment Analysis. Third one is the Research Center for Energy Conversion and Conservation. Next is the Research Center for Structural Strength Technology. Next, Research Center for Testing Technology and Standards. And next is the Research Center for Hydrodynamic Technology. And then the last, Research Center for Manufacture and Industrial Process Technology. Next, please. So the location of our research centers are mostly in the Serpong area. We call it the Puspiptek area. But one research center located in Surabaya, with the lab in Yogyakarta, and also there are 2 labs in Bandung for EV and for conversion and conservation energy. Next, please. So regarding to the reduce of GHG emission, we have a President Directive in November 2021 in the COP 26th. So we will contribute faster to the global net zero emission. And we strongly, with the G20 presidency last year in Bali, we have 3 main issues in this G20 presidency according to the net zero emission, namely the transition towards sustainable energy. And we also enhance the NDC to reduce the GHG emission in 2022 for around 32% or 43% with the international assistance. So with this President's directive, we have a roadmap, that's like a phase out for a coal-fired power plants, and then accelerating renewable energy utilization, energy conservation, utilization of electric vehicles, and so on. Next, please. So there are three accelerating action with accelerating clean energy sources development and on the implementation of energy conservation policy and the development of technology for carbon dioxide reduction. Next, please. So this is the profile of the Indonesia electricity with the sales increasing from time to time, also the power plant capacity and then also the electricity production. So most of them are with the fossil generation, around 85%. Yeah, and then the electricity production is for around 82% fossil electricity. Next, please. And we have also the renewable energy potential around the Indonesian, spread to all the Indonesian area. So from Sumatra until to Papua, with the solar potential is the most of them, the biggest potential. But the utilization is still small. Next, please. So we try to have a modeling this utilization of the renewable energy. So there, with the democratic indicator projection, next, we move faster. Next, please. And then with the more macroeconomic indicator projection with the GDP and so on. Next. Yeah, this is the projection, GDP sectors projection for sector industry, transportation, commercials, and other sectors. Next. And with the scenario that there are interconnection or the sea transmission between Sumatra, Borneo, and Java. Next. So we got this electricity demand by region and sector. So the around electricity demand in 2060 maybe we will increase until 2040 2.4 terawatt hour if business as usual, and with the net zero emission 1,880 terawatt hour. And this the projection of the sectors and also for the region. Next. So this is the power plant capacity projection, which it's we maybe put into the energy mix, the nuclear technology in around 2030 or 2040. Next. So we got this with this scenario. So the transmission, electricity transmission or power transmission is from Borneo to Sumatra and Java, and also from Sumatra to Java. Next. And we got the peak emission in 2032 with the amount of emission around 367 million ton carbon dioxide equivalent. Next. And this the accordance to the with energy sector development from the ESDM, which CFPP natural retirement here in the left bottom, and it's super grid and renewable energy sharing resources in the right side. Next, please. So we have for the INBRIN 2 programs about the energy research and innovation. So first is the new energy and renewable energy. So the new energy such as hydrogen, coal-based methane and gasification, coal liquefaction, and other energy sources. And renewable energies like geothermal, solar, wind, biomass, biogas, hydropower, waste, sea, wave and thermal, also a current, ocean current or sea current, and other renewable energy source. Next, please. So there are many activities of research and innovation in green, from optimization analysis and conservation until the gas emission concern. Also the for biofuel, hydrogen, and so on. Yeah. Next. I will show you some of the sample of the research and innovation in green. Next. Yeah. First of all is the co-firing technology development with biomass. So because we have planned to phase out the power plant generation from coal, so we have to substitute the coal with the biomass. So we research and innovate this co-firing biomass to power plant generation. Next, please. And second one is this binary cycle power generation. So we use the X-house thermal from the waste processing technology with the turbine and ORC, organic Rankine cycle. So we create the power with this X-house thermal from this waste processing technology. Next, please. So we also research and innovate about the hydrogen production and hydrogen utilization. So next please. So there are several production paths of the hydrogen: gray hydrogen, brown hydrogen, blue hydrogen, green hydrogen, pink and turquoise hydrogen. So there are many paths of the hydrogen productions technology also in Indonesia. Next, please. So next is the floating photovoltaic. So we built also this kind of floaters to support the floating photovoltaic. Next, please. And this is biodiesel and fuel conditioning and we contribute also with the research and innovation about the B20, B30, B35, and B40 this year, and maybe next year we'll another regulation about the B40. Next, please. And we develop also smart grid, which is we mix the EMS and SCADA, and we characterize the sun irradiation patterns, and also we mix the energy sources from the solar, wind, or water energy. Next, please. These are the pico and micro hydro. We developed the pico hydro with the specification a power about 250 watt with the small head around 1.7 meters or below 2 meters. And we also developed the micro hydro turbine vortex with the low head. We already installed in the Ciletuh Geopark. Next, please. And we developed also the charging station for 2 and 4 wheels, also AC charging station and DC charging station. And develop also the CSMS web and mobile mode. Next, please. Also in the marine energy, we develop also not only BRIN, there are also ITB and other institutes, such as oscillating water column, wave ocean energy, current energy, and also thermal, ocean thermal energy. Next, please. This is a kind of examples, like the twin turbine. We use this for current ocean energy with the floating platform and mooring system. And for wave ocean energy, we use also turbine platform, and for the OTEC, ocean thermal energy, we have the compartment that one the right side OTEC platform and the characteristics of cold water pipe. Next, please. So, in other research organizations such as nanotechnology and material, we develop also lithium batteries and supercapacitors for supporting the EV vehicle, electric vehicle. Next, please. And also the catalyst for bio liquid fuel. We use catalyst to convert the biomass or biomass to biofuel. Next, please. And also we developed the solar cell technology from the first generation, second generation, until the third generation now, with the hybrid inorganic and organic solar cells. Next. And then development also the perovskite of solar cell with carbon-based electrode. With the high performance perovskite with carbon electrode and upscaling of perovskite solar cell manufacturing. Next. And, this is a photovoltaic photoelectrochemical cell hybrid device for hydrogen production, with development of all inorganic based perovskite solar cell and also the integration of perovskite photoelectrochemical tandem cell for water splitting. Next. So the third one is the accelerating development of technology for carbon dioxide reduction. So we develop also the direct air carbon dioxide capture, which is this CCUS technology. Next. And also this development of biogas. We utilize the biogas from the pome, from the mill of sawit, kelapa sawit, oil palm. First, we can have the electricity from the direct combustion, but we can also utilize the biogas, compressed biogas, the production of bio CNG or biomethane. And the next one is the ongoing research is the green hydrogen and biomethane from the pome biogas. Next, please. And also the research and innovation from microalgae. So this microalgae, the current research topics of macroalgae is biogas production, subcritical water gasification, supercritical water gasification, and pyrolysis. And maybe the future research interest on this microalgae, the pigment production, rare sugar production, phosphorus production, active compound production, and integration of high-value chemicals and bioenergy production. Next, please. Yeah, this is the third one, the accelerating implementation of energy conservation policy. There are many policies and regulations in Indonesia about this implementation, the energy of conservation. Next. So what we have in BRIN, so we integrate the energy conservation laboratory. So from the energy audit, energy management, testing lab, water heater testing lab, domestic material and energy efficiency. So we integrate this all the labs for the energy conservation. Next, please. I think the last slide. So this is the green support for energy conservation program, the energy performance standards, energy management, human resource capacity building, research and innovation, and also research collaboration for energy efficiency. Next, please. Yeah, this for this conservation, energy conservation, we develop Icimece, Sistem Informasi dan Manajemen Energi, for using in industry or in building. Next. Yeah, this is the development of artificial intelligence for providers and energy users, with the data collection, AI models, validation, and also simulation. And the goals is net zero emission in the buildings or in the industry. Next, please. Thank you very much. I'm sorry for the time. Thank you very much.
Okay, giving applause, please. Thank you very much for your insightful presentation, Dr. Asnan. And ladies and gentlemen, now we come to the question and answer. Please don't hesitate to ask any question to our speakers today, Professor Miyazaki and also Dr. Asnan. You can press your hand and mention your name and your origin also. So please, in the Zoom, maybe you can press hand also in the Zooms. Okay, maybe I will start question maybe to Professor Miyazaki. Are you still with me, Professor? Already left? Oh, okay. So I will ask to Dr. Asnan. There are many research and development in BRIN and also usually policy it's also important to our the next step. How about the next step after research, and is it important doing research first or making policy first or collaborating together, because we have a challenge to net zero emission, and then new issue maybe from technology like hydrogen and fossil, etc. Maybe can you explain about that issue?
Thank you very much. A good question. So we are doing research, even though there is no policy about that things. Yeah, I think about the like hydrogen and so on. But we should have first the base of policy. Yeah. If we want to have or to make or to get the policy about the hydrogen, we should know how to produce the hydrogen and what is the dangerous things of hydrogen and so on. So that's why we are doing research before the policy is done. Yeah. So and then research and policy can parallel doing. We can do parallel research and policy. maybe that's is my answer.
Okay, thank you very much, Doctor. Maybe any other question? So maybe one question again, Doctor. What kind of energy, promising energy in the future from previous research already done by BRIN or maybe from another university researcher? What is the most maybe promising research which can solve the new materials maybe or new energy problems?
Yeah, okay. Thank you. Yeah, the promising energy, one of the promising energy, maybe not only the one, yeah, but one of these promising energies, resources is hydrogen. Hydrogen, because hydrogen can be used as electricity directly, or hydrogen can be used in the vehicles and other utilization of the hydrogen. But the solar energy is also the promising energy source, because we can found everywhere. Yeah, solar.
Very easy.
And very easy. So that's that we need is the technology to convert the solar energy to electricity energy and so on. Next, thank you.
Thank you very much. Okay, one question again.
Okay, good afternoon, sir.
Good afternoon.
My name is Anindia. I'm from Institut Teknologi 10 November. I am a doctoral student in the Industrial Engineering Department. I want to ask your opinion actually about the waste to energy. What is your opinion regarding the energy recovery that can be processed from waste such as plastic waste or maybe textile and garment product waste? I want to ask, is there any agenda at BRIN maybe or at the government about processing energy from textile and garment waste or clothing product waste? Because actually I'm currently doing my research about energy recovery from post-consumer textile waste, or we can call it maybe like clothing product waste, consumer waste. But I'd rather doing my research about the management of the supply chain, the cost of supply chain. And the practices actually have been done by many clothing manufacturer in Japan, but maybe in Indonesia itself, it hasn't been done. So what is the prospect actually, and maybe the future prospect of the energy recovery from waste, especially from textile and clothing waste in Indonesia, sir? What is your opinion about that? Thank you.
Okay, thank you very much, Ms. Anindia, for the question. Yeah, waste to energy itself, it's not currently, is not unfortunately, we cannot use this process or technology waste to energy only waste to energy itself, because the cost of this technology is very high. So that's why we can not use this technology by itself. So we have to mix with the other technology. Yeah. That's why the supply chain for the waste is very important, because the waste itself is not only plastics, but there are many kinds of waste. Also the textile, include the textile, the biomass, and so on. So that's why these kinds of waste we should have the different technology to utilize them all, not only waste to energy. Maybe that is my opinion. Thank you. The prospect of this waste to energy technology. There are so many technologies around the world developed to utilize the waste and convert to energy. So, which is the appropriate technology? We don't know. It depends on the kinds of waste and the location. Yeah. So that the prospect is, I think, have a more bigger and bigger prospect. Thank you.
Okay, thank you. Is that answer, Ms. Anin? Okay. Oh, one question again. Doctor, this is my colleague, Dr. Inayati from Universitas 11 Maret. Maybe this is the last question, maybe, because this is
thank you, Mr. President.
very critical.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Yeah, I'm Inayati from Universitas 11 Maret. I want to ask regarding the green plan about the hydrogen utilization. The question is the direction of the utilizing hydrogen for hydrogen-based internal combustion engine, or hydrogen will be used for the fuel cell for vehicle. Thank you very much.
Okay, thank you very much. Until now, we didn't decided which technology will use, because we want to compare the hydrogen directly used in internal combustion engine or to PMFC, solar cell. So which one is the appropriate technology? First, for the cost, and then for the location in Indonesia. So because Indonesia is unique, because there are many kinds of different locations. So in the cities, or there are small islands and so on. So that's why we don't decide yet. Thank you.
Okay, thank you, Doctor. We still have enormous and question and or issue, many question and issue, but however, to the limited time, we need to end this session. Thank you very much for Professor Miyazaki and also Dr. Asnan. Please give applause for him. Hopefully this session will be beneficial for us. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Engineering Engineer Pringgo Widiolaksono, for being an amazing moderator. And then before leaving the stage, we would like to give a memento that will be given by the moderator to the speakers. that we have finished our last panel session. That concludes our panel session for today. Ladies and gentlemen, our next agenda is lunch break.
Ladies and gentlemen, in a moment we will have a 1-hour lunch break. Please to all the participants to head to the designated area to enjoy your lunch. And after that, we will continue our next agenda, which will be the parallel session. For your information, ladies and gentlemen, all participants can enjoy lunch on the first floor of this building in Bayan Resto. Virtual parallel session will start at 1 p.m., which has already begun. Virtual parallel session will be held in several Zoom rooms with the following details in the web of Icimece. On-site parallel session will start at 1:30 after lunch break. All participants are asked to prepare themselves. Thank you.